The planet races through space. Its orbit is unstable, like a pool ball gliding across the table looking for a target to collide into. Only this ball is the size of Mars, and it's going 9,000 miles per hour. Boom! It crashes into another planet. This Mars-sized object was called Thea, and what it smashed into was Earth. The impact released 100 million times more energy than the asteroid that wiped out the dinosaurs. The planetary collision threw tons of solid material from both objects out into space. But only one of the bodies survived. Thea was obliterated and then swallowed entirely by early Earth. But that debris didn't go flying endlessly into the cosmic void. No, something crucial happened. All those solid chunks gathered into a cloud. Gravity squished it together, pressing more and more. And in the end, our moon was born. So goes the theory. At the time of the impact, the solar system was just forming, and this rendezvous of epic proportions probably wouldn't have happened if it weren't for a newly formed Jupiter throwing Thea off its orbit and straight into Earth. Our young planet withstood the blow. Time passed, Earth evolved. Its surface will become unrecognizable over the next 4.5 billion years. It's hard for the human mind to understand this vast amount of time, so we'll squeeze it all into one day. If midnight is when Earth first formed from gas and dust that remained after the Sun's creation, the next 4 hours show a lifeless planet. Red-hot, covered in lava, constantly bombarded by asteroids and, as you know by now, even a whole other planet. Yet life finds a way. The first cells appear. It's 4 a.m. on the clock. At 2:08 p.m., we see the first single-celled organisms form. It's not until 8:28 p.m. that sea plants appear. 20 minutes later, what's this? Jellyfish. After them, the planet flourishes with different fish, reptiles, insects. The forests grow at 10:30 p.m. Between 10:56 and 11:40, dinosaurs roamed the Earth. The giant lizards ruled our planet for less than 1 hour. A minute before the dinosaurs' extinction at 11:39 p.m., the first mammals begin to run around the planet. At 11:58 and 43 seconds, humans appear. In the cosmic scale of things, we've only ruled this planet for 1 minute and 17 seconds. So here's the main question baffling scientists. Why didn't life on Earth ever stop? It had every chance to cease. Why didn't our planet become like Venus or Mars? They both once had an atmosphere and oceans. Today, they're lifeless deserts. Forget about complex scientific concepts and theories of the universe's structure. Our little rock and all its inhabitants are just incredibly lucky. Professor Toby Tyrrell at the University of Southampton used computer programs and climate simulations to solve the puzzle of why asteroid collisions and ice ages didn't turn our little rock into a lifeless wasteland. The research team took not 10, 100, or 1,000 virtual planets similar to Earth. They used 100,000 for the experiment. And every single one of those 100,000 were simulated 100 times. They exposed these virtual planets to different phenomena. They were bombarded by asteroids, frozen, exposed to epic eruptions of supervolcanoes that blacken the skies and block the surface from the sun's rays. Just 9%, or 8,700 of them, were successful one time in 100 simulations. Of that crew, 4,500 planets remain inhabited 10 times. Only on one planet out of 100,000, life didn't stop all 100 times. If life is a lottery, Earth got extremely lucky. In 2009, the unique Kepler telescope was launched into space. Its task? Search one patch of the night sky, or 150,000 stars, for rocky Earth-like planets. Over 9 years in service, it ended up surveying more than 500,000 stars. In all that time, with all those observations over nearly a decade, Kepler discovered 2,600 possible Earth-like planets. The weird thing is, Most of them are a type you can't find in our own solar system. They're something between the size of Earth and Neptune. But back to the real Earth. If you go far from the city and look up at the sky, you'll see an ocean of stars. If you're lucky and it's a clear night, with an unaided eye, you could count a maximum of 2,500 points of light. Yet, there are at least 100 billion stars in the Milky Way. Some estimates put the numbers of stars in the Milky Way up to 400 billion. So, where's this giant range coming from? Well, counting stars isn't exactly an easy job. Scientists obviously don't number each one individually, 1, 2, 3, and so on. You know how long it takes to count just 1 billion? Over 100 years. Now, multiply that by 400. Instead, they look at small patches of space and use some complex scientific formulas to make educated guesses of how many stars there are in total. You can do a similar experiment yourself. Imagine a bucket filled with 10 pounds of rock, sand, soil, and other items. Your job? Understand how many rocks are in that mix. We'll count only those rocks that are visible to us from above. Get a rough estimate of their volume and weight, what percentage of the total we can see, and with some calculation, you can get a number. Is it exact? Nah. Why? Because you can't know if the rocks in the bucket are spread evenly throughout, or if they're all about the same size throughout. What if the ones at the bottom, if there are any, are bigger or smaller than your sample view? They could have completely different weights and volumes. That bucket is our Milky Way galaxy, and the rocks you are counting are stars. The point? Scientists can't know for sure how many stars there really are. Maybe 100 billion, or perhaps 4 times that. Of those, 4 billion are like our Sun. With our own galaxy, the most accepted estimate for planets that could potentially support life is 300 million. Though, as the tradition of scientific inexactness goes, that number could be up to 5 billion or more. Either way, lots of real estate to choose from. And that's just the Milky Way. But get this, it's just one of 200 billion galaxies in the observable universe. The most recent research puts that number 10 times higher, something like trillions of galaxies in space. And we've only studied less than 10% of them. As for how many stars there are in the universe, scientists put it at 1 septillion. That's 1 followed by 24 zeros. Again, it's all estimates because we can't know for sure. So far, one thing is clear. Our Earth is the only place in the universe that we know of where there's life. And this planet has done everything it can to change that. Over the past 540 million years, more than 20 major extinction events have occurred. The last one was 66 million years ago. Yep, it was the one that took out the dinosaurs, and 75% of all life on this planet for that matter. An object 7 miles across in diameter smashed into our planet. It was going 120 times faster than the fastest car today. Over 900,000 miles all around the impact site, everything caught fire. A huge tsunami swept across the world's oceans. Billions of tons of dust and sulfur rose into the sky and blocked the sun's warm rays. A global cooling came to Earth. A little over 200 million years ago, there was a lesser-known extinction event that wiped out half of all life on the planet. Most likely volcanoes or an asteroid strike are to blame. Other theories say the movement of tectonic plates triggered another ice age. At that time, huge crocodiles ruled the Earth. They disappeared, and new animals entered the arena of history – dinosaurs. But the worst this planet has ever seen was the Permian-Triassic event about 250 million years ago. 80% of marine life, 70% of land animals and plants, all gone. Volcanoes spewed out a colossal amount of lava where modern-day Siberia is, but it affected the entire planet. Around 445 million years ago, the dominant life form on our planet was marine invertebrates. There was only one continent, Gondwana, and plants were just starting to flourish on land. But something happened that took out 75 to 85% of all living organisms. It could have been an ice age, rising temperatures, or a more daring theory. Some think it could have been a huge star exploding 6,000 light-years from Earth. It launched a jet-like gamma-ray burst that ripped across space, and poor little Earth happened to be in its path. It burned off the ozone layer instantly. Yeah, we kinda need that thing to protect us. Case in point, no matter how much this planet, or even the universe, tries to wipe out life on Earth, which is here in the first place from unbelievable odds, life always finds a way.
You take off from Earth and park your spacecraft somewhere near the Moon. You're now almost 240,000 miles away from your home planet. That's almost 100 widths of the United States. Now you take out a giant hammer and an enormous chisel using the robotic arms of your spaceship. You place the chisel at the Earth's North Pole and strike its head with the hammer. Earth splits open like an eggshell, and you see it, another planet. It's Thea, and it's hiding inside our planet like a yolk in an egg. You'd need to go back in time 4.5 billion years to find out how it got there. This beautiful nebula will soon become our solar system. Colored dust and various space debris are slowly coming closer toward the common center. Soon this jigsaw puzzle of debris becomes too heavy and dense. The temperature inside the giant is rising. Soon, it gets so high that it triggers a nuclear chain reaction. Another second, and bam! There's an explosion so powerful that the shock waves travel far into dark space, and the blinding flash from this blast can be seen from the other side of the Milky Way galaxy. When the dust clears a little, you can see that a bright light is still shining at the very center of the explosion. This newborn star is the Sun. It weighs as much as 333,000 Earths. If the Sun was a bucket, you'd need 1.3 million Earth-sized planets to fill it. You're interested in a small object over there, 93 million miles away from the Sun. This pile of rocks and hot lava is Earth. Right now, the planet is busy forming its core, while the oceans of lava are gradually cooling down. But a few tens of million years after the Sun's birth, you notice a strange object hurtling toward Earth. It's Thea. This small planet was born at about the same time as Earth, and now it's following a crazy spiral trajectory at enormous speed. Scientists believe Thea was kind of a ball Jupiter and Venus played with. Venus was pulling Thea in one direction, then Big Brother Jupiter pulled it back. But the Sun makes up 99.8% of the mass of the entire solar system. That's why the star sets its own rules. It makes Thea move in almost the same orbit as Earth. So they inevitably come closer and closer to each other until they become next-door neighbors. We see that Thea is the size of Mars and as wide as the Atlantic Ocean from New York to Portugal. A collision can't be avoided. Thea is traveling toward Earth at nearly 9,000 miles per hour. That's 11 times faster than the speed of sound. If the smaller planet crashes into Earth at a particular angle, Earth will most likely be torn apart, as well as Thea itself. The collision will cause a huge blast, visible on other planets even on a bright day. Nothing will be left but some burning dust and debris. Even if Thea touches Earth only lightly, it'll still knock out a chunk of our planet the size of Australia. But the collision with Thea happens at a perfect 45-degree angle. It strikes the Earth at tremendous speed. The explosion literally vaporizes huge amounts of rock, and the shock wave sends the remaining debris into Earth's orbit. A huge crater is formed at the impact site. Soon, it gets filled with boiling lava. The remnants of Thea and the ejected fragments of Earth begin to orbit our planet. According to one version, these fragments form two moons. At first, they travel together, but one day, they get too close to each other and collide, forming one large space body. The other theory claims that all the shards start being pulled by the remnants of Thea. Sometime later, they form the moon as we now know it. At that point in the past, though, it's just red-hot rock and lava. The collision at this angle slightly tilts our planet and accelerates its rotation. It's because of Thea that we have different seasons and 24 hours in a day. Earth has lithospheric plates. These are enormous solid pieces that make up the crust of our planet. After the collision with Thea, they start to break and crack. It causes carbon, a primary component of all known life on Earth, to start moving all over our planet. So, Earth gets some kind of metabolism. After a few 100 million years, the first living creatures start to appear on our planet. Over nearly 4 billion years, simple single-celled organisms have been evolving into the life you see today. According to scientists, such a collision is a very rare event. The probability that somewhere out there, there's a planet like ours that has survived the same catastrophe is extremely small. This may be the reason why we are yet to find traces of other civilizations out there in space. Meanwhile, the remains of Thea are still here on Earth. Of course, it doesn't look like an entire planet stuck inside our own. Most of the fragments have melted and blended into the Earth's crust. If you take the top layer off our planet, you'll see 2 huge lava blobs the size of entire continents. They're right below Africa and the Pacific Ocean. Presumably, these are the remains of Thea. They didn't mix with Earth's mantle because of different densities. It's like mixing water and oil in a glass. The oil will always float up over the water and create an even layer on top of it. But if you raise those lava patches up to the surface, they'd be 100 times higher than Mount Everest. Other remains of Thea might be on the moon. The Apollo space missions brought back many soil samples for analysis. Scientists have concluded that the moon is very similar to Earth in structure. People could drill deep down and take samples there. Then they'd analyze the blobs from Earth. If their structure matched, it'd be 100% proof that Thea did hit Earth 4.5 billion years ago. And that's how we got the moon. But for the time being, Thea remains somewhat mysterious. Scientists are still not sure that the planet actually existed. The whole idea perfectly fits the model of the moon's creation. But in fact, this incredible collision may have never happened.
Hop on the bright side of life together with our brand new tees, hoodies, and more. Click the link to pick your choice.
Now you travel 41 light-years away from Earth to the planet 55 Cancri E. It's about twice the size of Earth and 8 times heavier. You take out your giant hammer again and use it to hit the chisel. The planet cracks, and you see it's a giant diamond. The temperature on this planet is tens of times higher than that of Earth, and its soil is rich in carbon. The heat puts a lot of pressure on this carbon. Its structure changes. First, it turns into graphite. Some more pressure, and graphite turns into diamond. On Earth, diamonds form at depths below 60 miles, where the pressure is 50,000 times greater than on the surface. The temperatures there rise over 1,000 degrees, which is as hot as fire. Diamonds are ejected closer to the surface in volcanic eruptions. Still, people have to dig mines 1,500 feet deep to find these beautiful gems. The Golden Jubilee diamond is the biggest cut and faceted diamond on Earth. It weighs as much as a chocolate bar and is the size of a hamster. Its price is about $12 million. Now imagine a diamond the size of an entire planet. You decide to fly back to the solar system. Your destination is Jupiter's moon, Europa. It's as wide as the distance between Seattle and Houston, and its mass is less than 1% the mass of Earth. Its surface is enclosed in an icy crust. It's about 19 miles thick. But what if you crack this crust with your giant hammer? Wow, Europa is completely covered in water. It's freezing here, 3 times colder than at the North Pole on Earth. The water turns into ice almost instantly, but the ocean beneath the surface is still liquid. Europa interacts with Jupiter gravitationally, just like the moon with Earth. This creates tidal forces and heats Europa's core. The core melts the ice around it. The result is a huge ocean, 2 to 3 times larger than all of Earth's oceans combined. Scientists believe that water is the basis of life. It may mean that life may exist on Europa. There could be thermal springs, just like at the bottom of our oceans. The water there is probably much warmer. And even though the pressure and temperature in such places are likely to be extreme, simple bacteria may live there. Europa is almost the same age as Earth. This means there's been enough time for living organisms to appear and evolve. Who knows? Maybe some advanced civilization is already blooming under this crust of ice. They may be building big cities and dreaming of conquering space right now. But the only thing people can do at the moment is send a probe to Europa and find out if life is possible there. "12 a.m. Young molten Earth collides with another planet called Thea. The moon is formed. From 12 to 4:30 a.m., the planet and atmosphere are morphing. The continents merge to form supercontinents. They break up again. This happens every 400 million years. That's every 2 hours on the clock. At 5:30 a.m., we see the first single-celled organisms starting their life in the ocean. It's 8 a.m. when the first viruses emerge. By 11 a.m., photosynthesizing bacteria have managed to take in enough sun to fill the atmosphere with oxygen. It takes 1 billion years. That's 6 hours on the clock. At 11:35, we have the first snowball Earth. Even the oceans turn to ice. Don't worry, everything will melt by noon. At 1 p.m., we have special cells with internal organs coming to life. 3 hours later, they'll start to divide into 3 groups that will eventually become fungi, like mushrooms. Let's fast forward while these cells go from simple to complex life forms. At 7:20 p.m., something familiar appears: sponges. It's 7:55, and the Earth freezes over again. It melts in 2 minutes. 8 p.m., and look in the ocean. We have the first comb jellies appearing. At around 8:30, the Earth's ozone layer appears. In just 2 minutes, the ocean is filling with plants. By 8:45, life is flourishing in the sea. We now have jellyfish swimming around corals. Starfish are on their way. At 8:52, we can see trails on the ocean floor. Creatures have begun to crawl. It's 9:10 p.m. The sea creatures decide to explore the land. 30 seconds later, different animals and plants emerge. They spread all over the planet in an instant. 9:41. It's time for the first insects. They feed on newly formed plants and trees on land. By 9:45, we have the first 4-legged animals appearing in shallow waters. At 10:10 p.m., those 4-legged creatures are splitting into groups that will later become mammals, reptiles, birds, and dinosaurs. By 10:30, everything vanishes. Mass extinction takes place. Either a huge asteroid or an enormous volcanic eruption causes it. Only 5% of the species survive. 10:34, and the dinosaurs are finally making an appearance. The first one was the Nyasasaurus, but experts aren't sure if it was the real deal or a relative turning into a dino. 10:45 marks another mass extinction. The early dinosaurs survive it and take the opportunity to spread all around the world. In 5 minutes, the Tyrannosaurus will appear. By 11 p.m., we have the first birds appearing in Europe. It's 11:15, and mammals are splitting into their groups. They'll branch out, forming whales, elephants, armadillos, and primates. By 11:17, dinosaurs are reaching their full size. The biggest one ever is the Argentinosaurus. It's the length of 10 school buses and tall enough to peek into a 7th floor window. It's 11:26 when a giant asteroid smashes into the Earth. Dust flies everywhere. A few seconds later, everything clears up, but the dinosaurs have already disappeared. With the dinosaurs gone, the few mammals left can take over the planet. At 11:30, the primates separate into 2 groups, and one of those will become apes, gorillas, and, sometime later, humans. It's 11:58 p.m. The chimpanzees and bonobos appear. 15 seconds later, the hominin species begins to walk on 2 legs. It's 11:59 and 23 seconds, the time when humans appear in Africa. A second later, they've migrated all over the world. They don't have a language, and they can't use or create tools. That happens at 11:59 and 58 seconds, 2 seconds before the day ends, 100,000 years ago. Our complex human species appears. Our universe is full of both amazing and terrifying things. You already know about quasars, black holes, dark matter, and so on. But how about the horrors of space that you haven't even heard of? Would you like to visit the most bizarre worlds in the universe? And it's not me who made this list, but NASA themselves. Welcome to the Galaxy of Horrors, NASA's awesome Halloween collection. Please join me on a journey to some planets and tell me which ones you would consider the most horrible. Buckle up. Our first destination is a gas giant called TRES-2b. It's located 750 light-years away from us. If we used a regular spaceship, it would take us about 10 million years to get there. TRES-2b orbits a yellow dwarf, a star similar to our Sun. It also weighs about 1.5 times more than Jupiter. So, what's so special about it? Well, if you're afraid of the dark, you definitely don't want to visit this place. It's the planet of eternal night, the darkest one of all the planets known to us. But it's not that far from its star, so why is that? The thing is, the surface of TRES-2b reflects light even worse than coal does. Because of this, it seems that there's no light at all. If you were flying across the surface of this planet, it would be like walking with a blindfold on your eyes. Oh wait, actually there is some light. An eerie deep red glow surrounds the surface of the planet. This glow is created by the burning atmosphere, which makes TRES-2b a scorching planet. The air there is even hotter than lava. Oh, but if you think that was bad, let me show you the next place of our horror journey. NASA wasn't beating about the bush while nicknaming this one. Now, we're not just talking about one planet, but 3 at once. They're also located quite far away, 2,300 light-years from the Sun. We would have reached them by ship in about 35 million years. All the planets are in the constellation Virgo, and each is extremely light, much lighter than the Earth. These 3 exoplanets are called Poltergeist, Dragger, and Phobator. Cool names, huh? It's because each of these planets is about to become a ghost soon. The thing is, they don't revolve around a star, but around a pulsar. Pulsars are rotating neutron stars with an extremely powerful magnetic field. In simple words, these are the stars that exploded one day. After the explosion, they usually emit such a powerful pulse that it causes the star to rotate at an unimaginable speed, several thousand rotations per second. At the same time, they constantly emit electromagnetic pulses that affect everything around them. So, you've probably already guessed what's happening with our zombie planets. They're slowly, gradually being destroyed under the gigantic influence of radiation. One day, they'll disappear without a trace. Ghost-like planets orbiting an undead star? Yeah, Zombie World is a fitting name. It's also not surprising that scientists nicknamed this pulsar Lich, despite the long official name. Well, at least these guys stick together on their final dance. This planet has a long name, so bear with me. HD 189733b. This gas giant is 65 light-years away from us. It would have taken around 1 million years to get there on a spaceship. This planet is slightly more massive than Jupiter and orbits its star, an orange dwarf, all alone. At first glance, it may seem friendly. A pleasant blue color and curls on the surface. Kind of resembles a summer sky or foam on sea waves, right? Oh, looks are very deceptive, my friend. This planet has a pleasant cobalt blue color due to the hazy blowtorched atmosphere. This atmosphere contains silicates that condense when heated. In other words, the clouds on this planet have rain made of glass. Yes, it rains hot glass shards here. Oh, and if that's not enough, there's a raging wind on the surface, which is moving at a speed of 5,400 miles per hour. Just to compare, the fastest wind on Earth had a speed of 254 miles per hour, about 20 times weaker. And because of this, hundreds of thousands of glass shards rush horizontally across the planet's surface at breakneck speed. I really don't envy anyone who would want to try to land there. By the way, this isn't the only example of strange rains in our universe. For example, it rains molten iron on the planet Dimidium. Or let's take so-called carbon planets. Their existence hasn't yet been proven, but if they do exist, there would be tons of black poisonous clouds, and it would rain pure gasoline and hot liquid asphalt. Oh, and also, raindrops would explode upon touching the surface. Nothing special. The next planet, though, is actually really strange. It didn't just revolve around its star, it lived inside the star. This cosmic miracle is called KOI 55b, or Kepler 70b. This planet is very far away from us, 4,000 light years. It would take about 70 million years on a spaceship. It's twice as light as Earth and fully rotates around its star in just a couple of hours. A long time ago, it was an ordinary Earth-like planet about the size of Jupiter. It was peacefully and calmly orbiting its red dwarf star, KOI 55. But everything changed about 700 million years ago. Perhaps you've heard that in a couple billion years, our sun will begin to expand into a huge star, absorbing everything in its path. Well, this is the fate of red dwarfs. Sooner or later, they increase, turning into incredibly hot blue giants. The same thing happened with KOI 55. This star began to increase in size and heat up in temperature, gradually turning into a blue-white giant. It was ready to devour its nearest planets, but KOI 55b didn't care about it. When the star reached it, this planet just settled inside. And moreover, after some time, it left its star, simply returning to the new orbit. How was that even possible? Life inside its star turned KOI 55b into a red-hot round stone. It's one of the hottest planets we've discovered so far. The temperature on it reaches 12,000 degrees Fahrenheit. It's hotter than the sun, which is, let me remind you, an actual star. And for some reason, it's still alive and lives as if nothing happened. Unfortunately, sooner or later, the planet will disappear anyway. It's slowly evaporating itself due to the incandescent atmosphere. But still, it somehow managed to survive the journey through the star, which isn't typical for regular planets, to put it mildly. I envy this willpower. However, not all planets are so lucky. Some are gradually being destroyed by their stars, and there is even an entire system among them. This last planet is a sad loner. It's located 870 light-years away from us. The journey by ship to it would take about 25 million years. This planet is about 1.5 times more massive than Jupiter. This is a very sad, dark planet. A doomed gas giant, which is very similar to hot Jupiter, orbits its star all alone. At the same time, it's located so close to its star that its orbital period takes just 1 day. Of course, because of this proximity, the star gradually absorbs WASP-12b. The scorching heat of the star is slowly destroying and devouring the planet's atmosphere. The planet has only around 10 million years left. But what's more interesting, because of this stretching, WASP-12b acquired the shape of an egg. It doesn't even resemble an actual planet anymore. It's also very hot. The surface temperature of the gas giant reaches 4,000 degrees Fahrenheit. Also, a spectrograph of cosmic origin, or COS for short, found that the planet exchanges matter with its star. They're located so close that they give each other part of their chemical elements. This is a common phenomenon in closely spaced binary star systems, but this is the first time scientists have seen this in a star-planet relationship. What a unique system. To be honest, if I was guaranteed complete security, I'd be excited to visit at least some of them. What about you? Please let me know in the comments.
Alright, let's imagine that humans have evolved to survive on very little oxygen. That means the Earth is now a no-go zone for us. And let's say that now we can live only on planets with little to no oxygen. It's time to build new homes on Mercury and Jupiter. So let's explore what life would be like if that happened. As you set foot on Mercury, you'll immediately notice how crazily bright it is. Mercury, being the closest planet to the Sun, is a never-ending summer vacation. Right now, it's scorching hot at a sizzling 800 degrees Fahrenheit. But since we don't need any water or oxygen, our bodies have adapted to the blazing heat and dry conditions of Mercury. Instead of overheating, our skin possesses a special protective layer that helps us handle these conditions. So, we're able to live there without any discomfort. How cool is that? On Mercury, the air is very thin. As a result, the sky there appears mostly dark and empty. The surface, however, is pretty colorful. It can appear orange and golden due to the planet's rocky terrain and the intense sunlight. All this creates some captivating views. Our activities would be super exciting. The gravity on Mercury is very weak, almost 3 times weaker than Earth's. So, imagine gliding through the air with incredible wingsuits, effortlessly soaring above the molten landscapes. So many possible cool tricks to show off. The buildings in this world are both imaginative and practical. They're made of special materials that can handle the heat and shine with a metallic gold color, reflecting the scorching sunlight. As you can see, our life in this small, hot world can still be pretty exciting. But let's move on to Venus. Now we've got ourselves quite a workload. This is the wildest and wackiest planet in the neighborhood. Temperatures there sizzle at a mind-boggling 900 degrees Fahrenheit. But guess what? Our bodies are cool with it. We can handle extreme temperatures. The winds there are crazy fast, reaching speeds of 224 miles per hour. Amongst them, we spot mysterious dark streaks that refuse to budge. Even scientists are puzzled by these streaks, which soak up ultraviolet radiation. It's like Venus has some secret party tricks up its sleeve. And speaking of parties, the planet is packed with active volcanoes, and they're always putting on quite a show. Molten lava flows and fiery eruptions are our daily dose of entertainment. Venus is similar in size to Earth, so the landscape feels familiar, but with a twist. It has a crazy amount of pressure that would make even the toughest creatures on Earth squirm. But not us. Our bodies are built to handle it, and we confidently strut around Venus like it's no big deal. Our cities shine like beacons, built with materials that can handle the intense heat and pressure. The metallic structures reflect the fiery glow of the Venusian sun. Inside, we've got super advanced cooling systems that keep us comfy despite the scorching temperatures. We surf on streams of molten lava, safely of course, and explore the volcanic landscapes. Pretty exciting, isn't it? But still, how about moving to a more friendly environment? Like Mars. Moving to Mars is one of our biggest goals. Its surface is a colorful canvas with hues of brown, gold, and tan. It's covered in rusting iron, regolith, which is like Martian soil, and dust. We would also be surrounded by volcanoes, impact craters, crustal movement, and mighty dust storms. As we gaze into the sky, we're greeted by Phobos and Deimos, Mars's moons. The sky itself is hazy and painted in shades of red, and becomes blue during the sunset, opposite to what we have on Earth. The temperatures on Mars can be quite extreme. Sometimes it's as mild as a comfortable 70 degrees Fahrenheit, while at other times it plunges to bone-chilling lows of around negative 225 degrees Fahrenheit. But once again, let's assume that our bodies have adapted to handle these swings. We've also developed ways to safeguard ourselves from meteorites and asteroids. These guys will be our frequent guests. The thin atmosphere of Mars doesn't provide much protection from them. Out of all the planets, Mars would be the easiest one for us to adapt to. Our next candidates, though, are not that hospitable. Living on Jupiter, the gas giant is a whole new level of adventure. Since there's no solid ground to walk on, we've come up with some super cool ways to call this place home. Picture floating cities like gigantic bubbles, suspended in swirling gases and liquids. They're specially designed to withstand extreme pressures and temperatures. To get around, we have jetpacks and hovercrafts. Imagine floating amidst Jupiter's majestic atmosphere, surrounded by cold, windy clouds of ammonia and water. These vibrant stripes and swirls paint the planet with a colorful palette. We zip through the colorful clouds, enjoying a mesmerizing kaleidoscope. Our homes and cities are filled with vibrant colors and shimmering lights. We've even created artificial gravity zones, where we can experience a semblance of gravity and walk with a bounce in our step. But be careful. Jupiter's powerful storms can be intense. Luckily, we have advanced weather prediction technology that keeps us safe. We watch the mesmerizing light shows of lightning dancing across the sky, marveling at the raw power of nature. All this sounds pretty fun, doesn't it? Well, what about the next gas giant, Saturn? Once again, we can live in the skies of Saturn, right among its beautiful rings. Our cities are like big, colorful balloons that sparkle and shine with bright lights. Inside, we have large domes where we can freely enjoy everything this incredible planet has to offer. Instead of walking, we use special devices that make us glide through the air, just like on Jupiter. In this extraordinary place, we had to discover new ways to generate power. We used the energy from Saturn's powerful storms. These sources of energy help us fuel our floating cities, giving us the electricity and resources we need to thrive. Saturn has many moons, and each one has its own special features. We've set up outposts on some of these moons, where we can go on exciting adventures and explore their mysterious landscapes. But if living on a gas giant wasn't challenging enough, we also have ice giants in our system. Welcome to the fascinating world of Uranus. Despite the super chilly temperature of -353 degrees Fahrenheit, we've come up with clever ways to make this place livable. To create warmth, we can learn from Earth's greenhouse effect. Like a cozy blanket, we can introduce special gases into Uranus's atmosphere that trap heat. Another idea is to build gigantic mirrors to capture and reflect the sun's heat. But let's be honest, it would be quite a challenge to position all those massive mirrors just right. Our homes are designed to withstand extreme conditions. We use dense fluids like methane, ammonia, and water to build structures that keep us warm and cozy. Our habitats provide shelter from the freezing temperatures outside. We may even discover new forms of life that have adapted to the unique conditions of this icy giant. Now that would be chilling for sure. And finally, we have Neptune. It is the cool and distant cousin of the solar system. Neptune's atmosphere is mostly composed of hydrogen, helium, and methane. There's also no water, only lots and lots of ice. But that's fine with us, right? So it's time to construct habitats. Let's envision another sky city. After all, who doesn't love the idea of floating cities amidst the clouds? Imagine gazing out from your sky city, observing the mesmerizing hues and swirling storms of this ice giant. The vibrant colors of the atmosphere would paint a breathtaking backdrop for our daily adventures. We'd explore the mysteries of Neptune's moons, delving into their icy landscapes and uncovering the secrets they hold. Hey, a world where humans don't need oxygen or water to survive doesn't sound that bad. We'd soar through the skies and roam vast landscapes. The only limits we would have would be the limits of our own imagination. So stay tuned for more captivating what-if scenarios. What will the end of the universe be like? It might be 100 billion years away. But here's the real question. Should we start panicking already? Jan Levin, a cosmologist, appeared at a recent screening of the captivating Netflix documentary, A Trip to Infinity. She mentioned that there would be a time when the last sentient being exists and the last flicker of thought fades away. This perspective sheds a whole new light on things. Somewhere in the vast expanse of the universe, there will be a moment when the memories of legends like Einstein and Elvis will fade away. Just imagine what that last thought would be. A brilliant pearl of wisdom, a colorful expletive. The possibilities are as endless as the stars in the night sky. Now let's take a cosmic detour and explore how we got ourselves into this peculiar predicament. As we currently understand it, our universe burst into existence with a bang approximately 13.8 billion years ago. Since then, it has been expanding at an ever-increasing pace. For decades, astronomers debated whether this expansion would continue indefinitely, or if a big crunch awaited us in the distant future, where everything would collapse back together. Everything changed in 1998 when astronomers stumbled upon a discovery. The cosmic expansion was accelerating. This turbocharged expansion was fueled by a mysterious force called dark energy, woven into space-time's very fabric. The larger the universe grows, the more this enigmatic force pushes it apart. It's eerily similar to the cosmological constant, a concept introduced by Einstein to explain why the universe didn't collapse, only to be discarded later as a blunder. But guess what? The cosmological constant turned out to be a stubborn idea that refused to fade away. And now it poses a threat to both physics and the universe itself. If dark energy triumphs in the end, distant galaxies will eventually speed away from us so rapidly that we won't be able to see them anymore. With each passing moment, our understanding of the universe will diminish. Stars will extinguish and never ignite again. It will be akin to living inside an inverted black hole where matter, energy, and information are swallowed beyond the event horizon, lost forever. The star-making days of our universe are behind us. Star formation reached its peak nearly 10 billion years ago and has been gradually declining ever since. The reason for this waning of stellar light is our expanding universe. As the cosmos grows larger with each passing day, the matter within it remains constant but gets spread out over more and more volume. To create a star, matter must be compressed into relatively small volumes. As the universe ages, fewer opportunities arise for such compression. So, in the far future, we can estimate that the last star will be born approximately 1 trillion years from now. This final star is likely to be a small red dwarf, a fraction of the mass of our Sun. Red dwarf stars have extraordinarily long lives, slowly burning through hydrogen in a steady fusion reaction, but eventually, even they will exhaust their fuel. In roughly 100 trillion years, the last flicker of stellar light will fade away. This accelerated expansion will progressively limit our view of the wider universe. Although we can still observe distant galaxies because of the light they emitted long ago, their current light will never reach us. As the universe expands at an increasing rate, the boundary beyond which galaxies recede from our view moves closer and closer. One by one, galaxies will be torn away from us by the relentless cosmic expansion, accelerating so swiftly that their light will forever elude us. Anything not gravitationally bound to us will be unable to withstand this onslaught. Only the local group, consisting of the Milky Way, Andromeda, Triangulum galaxies, and several satellite dwarf galaxies, will remain in our proximity. However, this lingering existence will be far from idyllic. Over time, our 3 galaxies will merge into one megagalaxy, completely isolated from everything else in the universe. In this solitary state, the megagalaxy will slowly dissolve. Chance interactions will scatter individual stars, or what remains of them, into random orbits. Some will be hurled into the giant black hole at the center of the galaxy, while others will escape into the void, never to be seen again. After an unimaginable span, no complex systems will endure. All that will be left are isolated islands drifting in an infinite expanse of darkness. To make matters worse, as thinking requires energy, there will eventually come a time when the universe lacks the energy to sustain a single thought. Eventually, all that will remain are subatomic particles, dancing in the vast expanse of intergalactic space, engulfed by eternal darkness. This will occur trillions upon trillions of years after the last glimmers of light and life have vanished. And then, countless eons will stretch onward to the point where even measuring the passage of time becomes impossible. As Brian Greene described it in his book, Until the End of Time, it's a tale full of sound and fury, signifying nothing. This might make us feel some sort of weight of insignificance in the face of this cosmic destiny. If this truly is the fate awaiting the universe, it's both humbling and disheartening. Our universe may be 14 billion years old, but that's just a fleeting moment compared to the unfathomable darkness that lies ahead. It means that everything remarkable in our universe occurred in a mere blink at the beginning, followed by an eternity of emptiness, its finality and futility on an unimaginable scale. But hold on a second. Before we surrender to despair, let's remember that we're still a long way from this inevitable end. New discoveries in physics could provide a glimmer of hope, an escape hatch from this fate. Perhaps dark energy is not constant. Maybe it will change its course and bring the universe back together. Michael Turner, the brilliant cosmologist who coined the term dark energy, emphasized that the cosmological constant would be the least interesting answer to the dark energy puzzle. So, who knows what surprises the future holds? But for now, we can't help but peer into the abyss and wonder. We are but brief inhabitants of this cosmic spectacle, here for the grand party when the universe brims with life and light. We may not have a say in the final act, but we can cherish the here and now, reveling in the magic of the present. As astrophysicist and philosopher John Archibald Wheeler once said, "The past and the future are mere fictions, existing only in the artifacts and imaginations of the present." From that perspective, the universe ends with each of us, granting us a unique perspective and a chance to make our mark. So let's embrace the fleeting nature of existence. Though the future may be finite, it liberates us to fully appreciate the wonders of this moment. After all, as the saying goes, nothing lasts forever, whether it's the stock market, the stars, or even our own lives. An awareness of eternity's whiff can illuminate the brilliance of a lifetime, even if it's just mine or yours. There is more than one theory about how the universe is going to be gone forever. In the world of quantum field theory, for example, we come across something called a vacuum decay. Picture it as a vacuum that's kind of stable, but not totally rock-solid stable. This false vacuum can hang around for quite a while, chilling in its semi-stable state. Could eventually say, "Nah, I'm done," and transform into a more stable vacuum. We call this wild event false vacuum decay. It's like a cosmic game of Jenga, where the unstable blocks finally collapse, and the universe finds its true balance. So, cosmic adventurers, let's treasure the Milky Way and all its splendor for as long as it lasts. And who knows, maybe in the vastness of this ever-expanding universe, there's still a surprise or two waiting for us. The story isn't over yet, and the cosmos is filled with secrets waiting to be uncovered. What do you think the end of the universe looks like for us humans? Are we even going to be around to witness it?
You wake up with a start, feeling disoriented. You were dreaming of waterfalls and green fields just a moment ago, but now your body is tingling weirdly. It feels as if you don't have enough oxygen to breathe, which makes you panic a bit. You open your eyes and look around. Oh, you're inside your sleeping capsule. Whew! Its walls are littered with different buttons and tiny screens. You press one of them, and one of the sliding panels sweeps to the side. You crawl out of your pod. The absence of your windows or any natural lighting makes you feel as if you're underground. Dozens of sleeping capsules line the walls. The door leading out of the dorm is made of metal. It looks heavy and unmovable. But once you press the button on the wall next to it, the door opens smoothly and soundlessly. After walking up a dimly lit corridor for a while, you find yourself in a smaller room. There's at least half a dozen bulky spacesuits inside. There's another door in the room. It looks even sturdier than the previous one. If you wanted to open it, it wouldn't budge. First, you need to put on one of the spacesuits. As soon as it's on, the door automatically unlocks. After waiting for a while in an airlock chamber, you finally make a step outside. You look up and see a beautiful blue orb. It seems to be glowing. It's Earth, and you're standing near your home base on the moon. You walk towards your Jeep. It looks nothing like cars on Earth, though. The vehicle you climb into is pressurized, and you can even take off your spacesuit, or at least your helmet, and ride in comfort. If you need to go outside, well, yes, you can't do it without wearing your protective gear. One of your favorite rovers, produced by Toyota, is the size of 2 microbuses and can easily fit 2 passengers and their gear. Of course, you've got the experience of riding it with 3 other companions, but duh, you were squashed like sardines that time. The vehicle can also unfurl solar panels to generate power. After dealing with all the tasks you had on your list, you come back to your lunar home. Unlike your house on Earth, it looks more like a castle. Due to the extreme temperatures on the moon, the lack of oxygen, the constant threat of meteorites, and the never-ending barrage of radiation from the sun, it has to be super sturdy. The thing is, on Earth, we're protected by the atmosphere. Most meteorites burn while passing through it, and it also protects Earthlings from harmful ultraviolet radiation and creates the pressure without which liquid water couldn't exist on the surface of the planet. On the moon, there's no atmosphere like that. The very weak one that exists on our natural satellite is made up of some unusual gases that haven't been found in the atmospheres of Earth, Mars, or Venus. That's why people living on the moon have to take care of these issues themselves. The first towns on the moon were built in craters and covered with protective materials, like plastic reinforced with a net made of titanium and UV-resistant superfiber. The inhabitants had to access their homes through airlock entrances dug into a mound. Bilbo Baggins would surely appreciate their aesthetics. On the moon, gravity is way weaker than on our home planet. And while it makes it easier for you to walk and even run on the satellite surface, even despite your bulky spacesuit, it's not great in the long run. That's why inside lunar bases, there's an artificial gravitational field. Without it, people would have problems with coordination, balance, and orientation in space. Plus, weight-bearing bones would lose 1% to 1.5% of mineral density per month. And there would be many other problems with health. Anyway, these days, along with old settlements located in craters, there are new towns that look like transparent glass spheres. They make a beautiful picture when you look at them while approaching the moon after visiting your family on Earth. Next to many of these domes, you can spot tall sun-reflecting towers. They can simulate the day cycle to help human bodies function properly, as they used to be on our home planet. Inside, there's a breathable atmosphere and fixed atmospheric pressure. The floors look as if they're made from regular concrete, but the material used in the construction is lunar dust. A colony on Mars would cost us trillions of dollars to construct and inhabit. It would take a long time for even one cargo ship to reach the red planet. But lunar towns are much easier to build and maintain. There are direct spaceship routes connecting the satellite with Earth. And you need just 3 days to travel between these 2 points. That's one of the reasons the colonies on the moon are growing, developing, and changing non-stop. When people first came to the moon with the intention of building settlements, their main concerns were producing energy and getting oxygen and water for a comfortable life. Now, you have trash can-sized nuclear reactors that provide the towns on the moon's surface with steady power. Plus, in some regions of the satellite, for example near the South Pole, there is near constant sunlight, which is great for getting solar power. That's one of the reasons why most lunar settlements are built in that area. Another thing that makes colonizing the moon easier is its ice. People living on the satellite use it to make hydrogen-oxygen rocket propellant. The main way to get the raw material is by using the regolith and ice drill for the exploration of new terrains. That's a piece of equipment designed for drilling in ice-cemented regolith and rock. This fuel is then used for cargo and passenger ships coursing between Earth and the moon. Right now, people are trying to derive oxygen and other useful products from lunar soil. More than 40% of the lunar crust is composed of oxygen. Of course, it's bound up in minerals in combination with other elements. These compounds are called oxides. You might have heard of quartz, aka silicon dioxide. It's the second most common mineral in Earth's crust. To move from one lunar town to another, you use moon Ubers, taxiing people and cargo. They're also called all-terrain hex-limbed extraterrestrial explorers, or athletes. They have 6 limbs that can grip cargo and roll or step over obstacles. Plus, they can switch out quick connect gripping and digging tools if you need them. They also carry people to and from launch pads, acting as lunar airport shuttles. But lunar towns aren't just placed where people live. They're innovative research hubs both for industry and science. They're also a popular tourist destination. Plus, people living there are tirelessly working on developing and constructing a special base for future Mars missions and the exploration of distant space. But let's have a look at how it all started. For instance, how the first lunar bases were built. Private landers descended on the surface of the moon and deployed inflatable modules, each around 4 stories tall. They served as residential areas, workspaces, industrial sites, and scientific labs. But those modules couldn't completely protect their inhabitants from harmful radiation, temperature swings, and the strikes of micrometeorites. So, people developed robots that could 3D print protective shells around each inflatable module. They used readily available regolith taken from the surface of the moon. It took the robots about 3 Earth months to finish solid domes. Some of these settlements were later connected with one another through a series of walkways linked to airlocks in each dome. At the same time, some of the towns remained separated, like those constructed in craters. When you visit Earth, you often look up at the sky, searching for your new home. Some of the lunar bases are visible if you're looking at them through a telescope. Others, partially hidden underground or covered with lunar rocks and soil for better protection, are almost impossible to spot. You're a seismologist working at a geological observatory. In the morning, you check the equipment that monitors seismic activity and adjust the instruments. Then you inspect the movements of tectonic plates. Suddenly, one of the devices shows a strange signal. It's like a small earthquake. You make a record of this push and continue working, but the signal repeats again. A little time passes and the devices fix it for the 3rd time. You understand that this is not an earthquake because the signal is too weak for this. It repeats every 26 seconds and resembles a pulse. The human heart pulses close to the center of the chest. The pulse of the planet also comes from its center, the equator. You call other specialists and tell them about the unusual phenomenon, but no one knows what it is. Also, you can't determine the source of the pulse. You arrive at the place where the vibration comes from and find nothing. The ground still pulses under your feet, but it's impossible to figure out the reason. In the 1960s, the pulse called microseism was discovered by seismologists in the US. More than 50 years have passed, but scientists around the world still don't know the nature of this phenomenon. It looks as if our planet has a heart hidden inside its crust, beating every 26 seconds. According to researchers, this heart may be located in the southern or equatorial part of the Atlantic Ocean in the Gulf of Guinea. This area is called the Bight of Bonny. Every winter, the pulse becomes stronger. Then it weakens again by the summer. When scientists began exploring this place, they put forward a theory that the ocean could create the pulse. Waves hit the continental shelf of the planet. That impact deforms the ocean floor. A human hand hitting a table works on the same principle. Sit on one side of the table and put your hands on it. Let someone else hit the table from the opposite side. You will feel a vibration. Ocean waves hitting the coastline create a similar effect. Someone may object that there are waves all over the world, not only at the equator. Yes, but that's where the sun heats our planet the most. Solar energy causes powerful storms and winds and accelerates ocean currents and waves. Also, in 1980, geologists found out that Earth's tremors became stronger during storms. In other words, when waves hit the shore with more power. Not all scientists agreed with this theory. Some researchers believed the planet was pulsating because of the seismic activity. It was coming from a volcano located on one of the islands in the Bight of Bonny. The place where the pulse was the strongest is close to the volcano. But further observations showed that the Earth's tremors happened in all parts of the Gulf of Guinea. That's why scientists can't prove any of these theories. Our planet pulsates not only from within. Earth is surrounded by a thin luminous halo. It's constantly changing its shape and shimmering with different colors. If you look at our planet using special equipment, you'll see that Earth is inside an uneven pulsating bubble. It's located at an altitude of 50 to 400 miles above Earth's surface. This bubble is called the ionosphere. That's a layer of charged particles that separates the upper atmosphere from space. In other words, this is the boundary that sets apart the region where you can still breathe and a complete vacuum of space. The International Space Station travels inside the ionosphere. Most of our satellites also move within the borders of the pulsating bubble. This natural phenomenon can both help and disrupt the operations of communication and navigation systems. It helps radio and GPS signals to get to our mobile phones, but it can also interrupt the stable connection. It all depends on the number and density of charged particles. Sunlight takes away 1 or 2 electrons from the gases surrounding our planet. and they become charged particles. These particles make up the ionosphere. It's constantly changing its shape and size. It happens because the planet rotates around its axis, and the sunlight falls on it unevenly. During the day, the ionosphere is always larger than at night. Because of this pattern, it's pulsating and constantly moving. This instability shortens the life of orbiting satellites and often puts them out of work. Radio and GPS signals pass through the ionosphere and get reflected from charged particles. Then, they fly further to their destination, to phones, navigators, and other devices with GPS and radio receivers. Our planet is not only pulsating, but also buzzing. The noise that Earth produces is called the hum. It's impossible to record this sound, but even so, 2 to 4% of people on the planet hear it. All over the world, people who aren't connected in any way speak about a weird buzzing sound. It interrupts their sleep and doesn't let them concentrate. This noise follows them everywhere. Perhaps you also hear it but don't pay attention. But once you notice the hum, you won't be able to unhear it. Some residents of a small village in Scotland describe this humming as a thick, low-frequency sound. There's a website on the internet with a map where people all over the world register and describe this mysterious noise. Almost everywhere, it's a low-frequency vibration, barely perceptible to the human ear. Sometimes, people say it resembles the noise of an airplane flying overhead, but quieter. Some people describe it as the sound of a running truck engine placed in the backyard. It's humming in the street when they come home. And it gets louder when they are lying in bed. If you hear it too, you can mark it on the map. There are records dating back to the 19th century that describe a sound similar to the hum. But for the first time, the media started talking about this phenomenon in the 1970s in England. Since then, many theories have been made by scientists and people who try to catch the hum. There is a hypothesis that claims the noise comes from high-speed traffic on highways, or it might be caused by too many airplanes flying in the sky. The hum and vibrations can be produced by electric stations, factories, industrial equipment, and huge air vents. Some people believe the reason for the hum is the movements of tectonic plates and the Earth's crust under the ocean waters. But no one has managed to prove it yet. In most cases, people hear the hum in big cities, and, of course, they often complain about this and demand to conduct investigations. But all the attempts to find the source of this noise haven't given any results. It's possible that 4% of people have a unique hearing that catches low-frequency sound waves. One theory says the source of the hum is special radio signals. They're used around the world to communicate with submarines. These radio signals can make people have a response. It feels as if you hear some buzzing. This happens when radiant energy collides with the soft tissues of the human skull. It stimulates the auditory nerve and creates an auditory hallucination. But the coolest theory appeared in the city of Sausalito in California. A lot of people there hear the hum, and biologists believe that fish might be the reason. There are many toadfish on the west coast. They can produce a unique sound that is not audible itself, but the sound wave coming from the fish resonates with the buildings located near the coast. This resonance produces the hum. Even one fish can do this. Imagine what happens when thousands of these sea creatures scream at the same time. But not only people living near the shore have problems with the noise. Those who live in the city center hear the hum too. And since the sound waves created by the fish can't spread so far, the theory was quickly refuted. Our planet isn't the only humming one. In 2020, scientists recorded a strange buzzing sound on Mars. This is a quiet, long beeping that spreads across the red planet's surface. Sometimes it changes a bit because of Marsquakes, which are another mystery. Earthquakes occur on our planet because of the tectonic plates' movements. Stress accumulates and gets released in the crust. This produces earthquakes. But there's no plate tectonics on Mars, so Marsquakes aren't supposed to be happening there.
Look up when the sky is clear at night. You'll see thousands of tiny bright dots there. It may seem like they're fixed in one spot, but in reality, they're constantly moving. In 100,000 years, there won't be a constellation with the same shape or pattern we know today. And think about all those red dwarfs, small stars, planets, space bodies we can't see with the unaided eye. Red dwarf stars are especially cool. They're usually about half the size of our sun, and mostly 1/10 as bright. They may not be the brightest things in the sky, but they live for a very, very long time. Nuclear fusion reactions happen deep in star cores. That's what makes them shine. Large stars release huge amounts of energy, burning their stellar fuel. But such stars tend to burn all their fuel in only a couple of million years. Stars like our sun usually live for about 10 billion years, but red dwarfs don't use that much of their fuel. Their light is not so powerful, and they don't require much energy to support their existence. They're like energy-efficient cars. That's why they can last hundreds of billions of years. Some of the smallest ones may live for up to 10 trillion years. Most hydrogen in sun-like stars remains unspent. There's more of this gas in the atmosphere rather than in the core of such stars. This means most hydrogen doesn't take part in the fusion reactions. But it's different with red dwarfs. They circulate plasma throughout their entire bodies. These stars pull fresh hydrogen reserves from their outer layers into their core. That's what keeps fusion reactions running. One day, in the distant future, stars like our sun will run out of fuel and shut down. The universe will be full of small red dwarfs. They won't have enough energy to shine and brighten the space around them. Our descendants, if there are any, will inherit a dim, dark cosmos. As it gets older, the sun will balloon to a size where it will destroy nearby planets. First Mercury, then Venus, and then us. On the other hand, Earth will probably survive, but barely and not for long. The sun will burn it to a crisp when it gets closer. The outer planets of our solar system will also survive, but they'll move even farther away into space. The sun will lose some of its mass while increasing in size. Its gravitational pull establishes the orbits of the planets. When our star becomes less massive, the pull of its gravity will become weaker, and the outer planets won't have such a strong connection with the sun. Our solar system is not isolated. There are many other stars in our galaxy. Within 30 billion years, stars that travel nearby will mess with our outer planets, enough to rapidly launch some of the biggest ones out of the solar system altogether. The last planet to stay will stick around for a while longer, maybe even 100 billion years. But even that one will eventually end up kicked out of the solar system. There's a theory claiming that we got most of the water on our planet from ice-laden meteorites and comets, frozen balls of ice and dust. As they crashed into the early Earth, they probably brought water, which was necessary to develop life. But those very same objects that might have created life on our planet could also be its end. This is not a matter of if, more a matter of when. And scientists think it's very likely that an asteroid or comet big enough to wipe out life on Earth will smash into our planet. But it'll happen in the distant future. And fortunately, we have the technology to predict such things and react on time. But there are other cosmic collisions we can't avoid, no matter what we do. Andromeda, our neighboring galaxy, is moving toward the solar system at a speed of 68 miles per second. There are 2.5 million light years between the Milky Way and Andromeda, so luckily our neighbor won't cover that distance anytime soon. It'll only happen in around 4 billion years. Such a collision of two galaxies might lead to real chaos for our descendants, if any of them are still living on Earth, that is. The two galaxies will slide past each other. Then they'll draw apart until the gravitational force starts pulling them back together. As they merge, they'll both lose their disk-like structure and form one big elliptical galaxy. It's already got the nickname Milkomeda. The Milky Way as we know it today won't exist anymore. Space is in constant motion, changing all the time. Scientists have a couple of possible scenarios of what might happen with the universe in the future. Number 1, the Big Rip. This theory claims that the universe will expand infinitely. At one point, the pull of the expansion will get stronger than the gravitational force keeping it all together. If this happens, it will tear apart galaxies, stars, black holes, and all other space bodies, including Earth. The universe will turn into a bunch of disconnected particles. Until about 5 billion years ago, the universe was expanding slowly because of its powerful gravitational pull. Then its growth sped up. Some experts say it happened because of the effects of dark energy. Dark energy is a mysterious force that makes up almost 70% of our universe. This force pushes it to expand faster rather than slowing it down. So, in the case of the Big Rip scenario, dark energy will win over gravity to the point where it will be able to rip apart individual atoms. Scenario number 2, the Big Crunch. There's a possibility the universe will get to the point where it'll stop expanding. Gravity will become a dominant force. It might even reverse the expansion of the universe. Then, the cosmos will start shrinking, making planets, stars, and even entire galaxies collide. In the end, the whole universe will collapse in on itself. Once everything compresses into one infinitely small point, which is something called the Big Crunch, the universe may start expanding once again. Theory number 3, the Big Freeze. Brrr. In this scenario, entropy will grow until it reaches its maximum value. Entropy is basically the idea that everything in the universe declines into disorder at some point. Once entropy gets to its maximum, the heat in the system will be spread evenly. The universe will then disappear because there won't be any room for heat to exist. Any mechanical motion inside the universe will stop. The cosmos will be so empty and gas will be so thin that no new stars will be able to form or shine again. In such a cosmos, time is just an endless void. Nothing ever happens with planets, stars, or living beings. The entire universe is frozen, dark, and motionless because there's no energy that can make things start working again. Many, many billions of years after the last stars burn out and fade, black holes will send a message that the universe has come to an end. Black holes are areas with extremely strong gravitational pull, so powerful that nothing can escape it. They can be as massive as 100 suns. As for supermassive black holes, their mass can be greater than that of 1 billion suns. You can find such giant black holes at the center of most galaxies. Like everything else, black holes will experience the same end. But when their moment comes, they won't gently disappear into the night. Black holes will go away in enormous bursts of fireworks, lighting up the universe in the last moments of their existence. It will be the end of the entire era. Black holes usually survive by gobbling down the stars and gas that come close enough. Their gluttony is the main feature that gives them away. In most cases, there's an accretion disk around a black hole. That disk is made of all those materials and particles it's torn apart and is pulling inside, similar to when water swirls down a drain. As the materials and particles draw closer, they start to move faster and faster. This generates heat, which makes the accretion disk glow, which again gives away the black hole. Yep, black holes aren't that great at hide and seek. Things that cross a black hole's event horizon, which is also called the point of no return, are lost forever. But Stephen Hawking had a theory that you might be able to escape from a black hole. There are particles moving even in a vacuum. Let's say one particle has positive and one has negative energy. If they both come close to a black hole, there's a chance that one will fall into it while the other will escape. That means the black hole has radiated the particle away. And this particle has taken some of the black hole's mass with it, which is why the black hole may start shrinking. As it begins to evaporate, it loses its mass and slowly becomes smaller. More and more particles start leaving until all the energy that's left behind escapes all at once. In the final tenth of a second, there will be a giant flash of energy and light in a very, very small region of space. And then, it's all gone.
84 million years ago. Many modern mammals, birds, insect groups, even the first flowering plants are already there. Dinosaurs are still roaming around. They have around 20 million years left before the asteroid. T-Rex, a fearless hunter, becomes the king of the dinosaurs. In the Earth tilted by 12 degrees. Picture our planet as a chocolate truffle. The shell is hardened, the center is viscous, with semi-solid matter. Its top layer, the crust, consists of tectonic plates that are like puzzles. Continents and oceans come on top of these plates. 84 million years ago, the mantle and the crust started rotating around our planet's outer core, then going back. If you'd been able to see it from space, it would have seemed like the entire planet has tipped over on one side. Today, it would have moved New York City to where Florida is. Let's say our planet is like a spinning top. It whirls perfectly if the weight on the top is evenly distributed. But if you move some of the weight to one side, it makes it tilt. It may have been caused by the moving of the tectonic plates and one of them sinking under another. We might be drinking water older than our solar system. Some scientists think the water we have on Earth may have come from ice specks that were floating in some sort of a space cloud more than 4.5 billion years ago. Lakes aren't always peaceful and relaxing. They can also explode. It happens when there are volcanic gases under the surface that can burst, rise to the surface, and cause big damage. The Earth's rotation is slowly going through time. Every year, the moon gets a little bit of energy from our planet and slowly drifts farther away from it. These two things are making our day longer, but really slowly, around 1.4 milliseconds every 100 years. That means when dinosaurs were around, the day was 23 hours long. Our planet used to be purple. One theory says ancient microbes didn't rely on chlorophyll to absorb the sun, but on different molecules. They absorbed green light and then reflected back a nice purple color. Every time you take a dip in the ocean, remember you're swimming above more than $700 trillion worth of gold. Not on the ocean floor waiting for someone to get it out, but in tiny particles dispersed in the water. The deepest place on our planet is the Mariana Trench, a spot in the Pacific Ocean, 36,201 feet under sea level. But the deepest place that's not covered in the ocean is in Antarctica. Technically, it's hidden below thick and deep layers of ice, goes more than 8,300 feet below sea level. There are 60 tons of dust falling from space to our planet every day. You probably inhale a pretty good amount of this cosmic dust while just going to work. It's dust, small particles from comets, meteorites, and some other space bodies. Dalal, Ethiopia, is the hottest inhabited place on our planet. Between 1960 and 1966, the temperature was 106 degrees Fahrenheit, and even in the wintertime, the temperature goes up to 98 degrees Fahrenheit on average. 8 minutes and 20 seconds. That's the time sunlight needs to travel from the sun to our planet. It's still not that much compared to what it takes for the light to reach Pluto, 5.5 hours. Almost 70% of the fresh water we have in this world is held in ice sheets and glaciers. More than 96% of the total amount of water on Earth is in the oceans. The Earth is like some sort of big magnet. Its inner core is actually a sphere made of solid iron, with liquid iron surrounding it. All those variations and changes in density and temperature create some sort of force, which makes the iron produce electrical currents. They are lined up by the planet's spin, and together, they create a magnetic field. There are many stars in the Milky Way, 100 billion, but way more trees on our planet alone, around 3 trillion. You can tell how old the tree you're looking at is by its rings. They can also tell you more about the conditions of a given year, too. When these rings are thin, there was a drought, while the thick ones say it was a rainy period. Earth is a magical planet where even rocks can walk, at least some of them, in Death Valley, California. They leave trails so you can record the path they've passed. Some of those biggest rocks have left tracks behind up to 1,500 feet long. Smooth-bottomed rocks wander around, while those with rough surfaces tend to leave straight tracks. The world that surrounds us consists of atoms, and they seem to be solid. But 99.99% of them are just empty space. An atom is just a really small nucleus and a cloud of electrons surrounding it. These electrons are particles, but they act like waves. They don't exist in one point but are spread over a range of probabilities and occupy lots of space. Take the empty space in our atoms, and all the humans could fit in a really tight space like the volume of a sugar cube. Australia is slowly shifting north, 2.75 inches per year because of tectonic movements. Australia is one of the top continental tectonic plates that move faster than others. You'd need 400,000 moons to reach the level of brightness the sun has. Sounds a lot at first, but the moon only reflects the light coming from the sun. It doesn't make its own. And even though that's not enough, its brightness depends on the exact angle between the sun, moon, and the Earth. The planet we live on used to have 2 moons, or at least some scientists believe so. They figure the side of the moon that faces the Earth is relatively flat and low, while the other side is way thicker and crustier. The theory says that there used to be the second moon that collided with the thicker side. Some believe there's still a second moon. It could be not a giant space body we see clearly in the sky, but some sort of a small asteroid pulled into the Earth's orbit. Air doesn't mostly consist of oxygen. Almost 78% of it is nitrogen. If you want to see some pretty steep rocks, go to Canada, Inuiatuk National Park. It has the biggest vertical drop in Canada, the tallest and the steepest cliff, with 105 degrees of overhang and 4,000 feet of rock. A team of 4 American men finally made it to the top in 1985, although there were 30 attempts for that before. It took them 33 days to get up. The Pacific, Atlantic, Indian, and Arctic are the 4 world's oceans. The 5th is confirmed to be the Southern Ocean. It's not defined by the continents around it, but by its Antarctic current that goes from west to east. Research shows this current was created more than 30 million years ago when South America and Antarctica had separated. This allowed water to flow around the bottom of the ocean without any barriers. Melting glaciers and ice sheets means more water in the oceans. It adds the extra weight of all that liquid pressing down the sea bottom, making it sink. The Earth's surface looks solid and kinda permanent, but every 500 million years, it goes through a process of regeneration. Tectonic plates crash into each other. Continental crust creates pressure on the oceanic crust, and that pressure activates the volcanoes. Through time, all this results in regenerating and replacing a majority of the Earth's surface, just like our body regenerates skin cells, replacing old with new ones. Out of all planets in the solar system, Earth is the only one with the outer crust that's broken up into huge surfaces we call tectonic plates. This is an important process that allows the formation of oceanic trenches and mountains, and also helps with protecting the Earth. When microscopic planets that live in the ocean are gone, they fall down to the bottom. The remnants go back into the interior of our planet and get recycled, and eventually end up in the atmosphere, protecting us from overheating and turning into Venus, the hottest planet in our solar system.
Uranus is an enigmatic giant that has puzzled astronomers for centuries. But what sets this gas giant apart from the others is its strange tilt. While most planets spin on an axis that is perpendicular to their orbit, Uranus takes a wild spin in a different direction. But why does it look like this? How did the planet turn out to be lying on its side? And what would we see if we visited the surface of such a planet? Let's find out. Uranus, the 7th planet from the Sun, is a cosmic oddball and source of many jokes. It's one of the gas giants in our solar system, along with Jupiter, Saturn, and Neptune. It's also the 3rd largest planet in our solar system, with a diameter of about 31,000 miles. And one of its many oddities is a weird rotation on its side. Not all planets in our solar system are aligned in a straight line. While most planets in our solar system have an axial tilt of less than 30 degrees, Uranus is tilted at an angle of almost 98 degrees. It's like that one friend who always has to be different, even if it means standing on their head to prove a point. So its north and south poles are facing east and west. It's like the planet got lazy and just rolled over one day, deciding to take a nap. And why is Uranus so tilted, you ask? Scientists once thought this was due to some kind of collision. They thought that something gigantic crashed into Uranus, something like what happened to our Earth. A dwarf planet crashed into it, the Earth tilted slightly, and the Moon was born from the remnants of the collision. But this theory had a problem. In the early universe, there were a bunch of asteroids, dwarf planets, and other large objects. And if this is so, then why is only Uranus tilted? All sorts of guys have crashed into other planets too, but they don't have such features. But recently, scientists have published a new study, and now scientists think that the culprit might be a long-lost moon that wandered away. Back in the days of the early solar system, the giant planets partied much closer together and way closer to the sun. But, as we all know, parties can get out of hand. Something caused Uranus and Neptune to migrate the farthest, like they were trying to get away from the sun's strict supervision. Each giant planet had a collection of moons, but they were constantly getting shuffled around during all this migration madness. Some planets lost moons, while others gained new ones. Uranus could have been born with a massive moon, or quickly captured one, and if that moon was big enough, it could have started playing games with Uranus's spin. This moon pulled on Uranus with its gravity, making the wobbling even worse. As time went on, it made Uranus tilt more and more. Eventually, it crashed into the planet, locking it into its current tilt. While the theory is pretty sound, based on computer models, we'll have to wait until at least 2030. That's when China plans to launch the Tianwen-4 spacecraft to take a closer look at Uranus and study it more. Who knows what other crazy space secrets we'll uncover next? Until then, we can all have a good laugh about the lazy, rebel planet that just can't seem to stand up straight. Such a funny and unique feature makes you wonder, what exactly would we see if we were standing on this planet? How would its strange tilt affect the view from its surface? Let's see, if you were standing on the surface of Uranus, although it doesn't really have a surface, it's more like a gas atmosphere, you'd enjoy a cool view. You'd see the sun rise in the east, just like on Earth, but then it would keep going around the sky in a tilted path, like a lazy spiral. About the sunset, though, I hope you have some patience, because it would take 42 years for the sun to complete one full circle around Uranus's sky. That's a really long time to wait before finally going to bed. But speaking of the sky, it would be a beautiful sight to behold. Uranus is known for its stunning, unique blue-green color. It's caused by the methane gas in its atmosphere. Methane absorbs red light, giving Uranus its cold hue. You'd also see some amazing clouds and storms swirling around the planet. But if you're looking for constellations, you're out of luck. The extreme tilt of Uranus means that its poles face towards the sun, so the stars would be all over the place in the sky. The constellations that are familiar to us would be unrecognizable from Uranus. Also, as the planet rotates, the position of the stars would change very often. For you sailors out there, good luck in navigation. But you could see its beautiful moons. Uranus has 27 known moons, with the largest being Titania, followed by Oberon, Umbriel, Ariel, and Miranda. These moons are thought to have formed from the same material that formed Uranus, and yes, the tilt affects them too. They orbit around the planet perpendicular to the planet's motion around the sun. And they aren't the only ones. Did you know that Uranus also has rings? Yeah, not only Saturn is so special. The rings are made up of ice particles, some as small as grains of sand, and others as large as several feet across. They're thin, narrow, and dark compared to Saturn, for example. They're actually so black that they almost don't reflect the light. That's why it's so difficult to see them from Earth. But if you were near the surface of Uranus, you might be able to see them in the sky. The only question is, would you even be able to focus on all these views? Because Uranus is extremely cold, and that will probably be the only thing you'd think about. We're talking about temperatures that can drop down to negative 350 degrees Fahrenheit. Brr, better pack some warm clothes for this trip. This is because it's so far from the sun, and its atmosphere is composed mainly of hydrogen and helium. And not only is Uranus the coldest planet in our solar system, but the winters there are long. Due to the extreme tilt, it has seasons that last for over 20 years. It's like the planet is stuck in a perpetual state of winter, which is both cool, pun intended, and kind of sad at the same time. And if that's not cold enough, Uranus is also known for its strong winds. In fact, they can blow up to 360 miles per hour. So you might want to hold on tight to something, or wear a windproof suit to avoid being blown away like a leaf. And finally, Uranus's magnetic field is also tilted at an angle of 59 degrees from the planet's axis of rotation. This creates some interesting effects. The most obvious one is beautiful auroras, which are similar to the northern and southern lights on Earth. On Uranus, however, the auroras are located near the planet's equator rather than at the poles. Isn't that cool? The result is a dazzling light show that would make even the most jaded space traveler stop and stare in wonder. But even though it sounds pretty awesome, it makes it more difficult for spacecraft to navigate around Uranus. The magnetic field creates a lopsided gravitational pull that can affect the trajectory of spacecraft. This makes exploring Uranus a bit more challenging, but maybe it will change in the future. All in all, standing on Uranus would be a chilly, wobbly, and breathtaking experience, and definitely not your average stroll in the park. Next time you look up at the night sky, think of this beautiful icy planet, and remember that even in the vast expanse of space, there is always something new and exciting to discover. You're inside a small spaceship. You're flying higher and higher, then leave the atmosphere of our planet. Hundreds of thousands of satellites with glowing advertising banners appear in front of you. One of them says, "Happy New Year, 5699. This year you have an anniversary. You will be 5,000 years old." You press a button on the touch panel and activate the ad block. Now you can't see any holographic banners through the glass. You're going to make a jump through space. A black tunnel called a wormhole appears in front of the ship. You fly inside and the hole disappears. The ship has teleported to the Andromeda Galaxy. You discovered an exoplanet here recently, similar to Earth. It's also blue, has a lot of water, but only one huge continent. The planet is hidden in dense interstellar clouds, and you hope that other people won't find it soon. But as soon as it's entered into the intergalactic register, you'll definitely buy this planet. You call it second home. Now you're flying into the atmosphere, going through the clouds, and landing on a small green hill. At the foot of it, you see several small houses made of clay and stone and thatched roofs. Near the houses, locals are working in simple clothes. They're plowing the ground, and cows are eating the grass nearby. You have turned on your stealth mode, so the locals can't see you. They aren't real people. You created them using cloning technology. The conditions on this planet are now the same as they were on real Earth in the year 699, the year when everything changed for you. You remember swimming in the lake at night and looking at the stars. One star moved from its place and began to approach. A huge flash of light and something heavy fell into the water. You lost consciousness and woke up in the morning on the shore. Only 1,000 years later, you realized it was a meteorite. The day after the star fell, you noticed that any damage on your body instantly disappeared. After a couple of decades, you realized that you get older slower than the rest of the people in your village. After another 50 years, you understood that you didn't age at all. Knights, Vikings, the Dark Middle Ages, the geniuses of the Renaissance. You see it all with your own eyes. You become an emperor of a huge empire, and then you get bored and decide to live in the slums to feel all the shades of this life. You think that some magic gave you immortality, but then you realize that any magic or sorcery is really science. You communicate with the greatest minds on the planet, make friends with incredibly bright people, and really bad ones to understand the nature of humans. Around the 15th century, you've got all the knowledge and read all the books that people could give you by this time. You begin to explore the world yourself. You discover the process of photosynthesis in plants, grasp the fundamental laws of physics, conduct amazing chemical experiments, and find out that you live on a tiny planet in an infinitely vast universe. Biology, chemistry, physics, astronomy, you learn and explore everything. The results of your scientific research in these subjects are ahead of humanity by 100 years. While the whole world is riding horses, you're already building a car with a steam engine. To hide your identity from people, you constantly change your name and place of residence. Over 1,000 years, you have learned all the languages of the world, and even those that no longer exist. You study all the psychologically known personality types. Your social and emotional intelligence is so developed that you can create a person's portrait after 1 minute of talking to them. You look into their eyes and understand what they want, are afraid of, or are ashamed of. You spend several years in continuous meditation to calm your mind and gain wisdom. You lead the life of a hermit and watch humanity slowly develop. But then, the 20th century comes, and the life of the entire planet changes dramatically. The Industrial Revolution, the first cars and trains, cinema, radio, and television. In these 100 years, people are changing more than they have in the previous 1,500 years. Now, it's hard for you to keep up with the world. New inventions appear every day and every hour. The knowledge and experience of previous years help you become one of the most influential people on the planet. World leaders listen to your opinion. Thanks to your developed communication skills, you can negotiate with any person. You go through expensive and high-quality plastic surgery operations so that no one will recognize you. You keep moving and getting a new ID every 20 years. You have a lot of money, as well as gold and other valuable metals that you've collected for centuries. You build houses and shelters in the most beautiful places on the planet. You finance the development of new technologies. Sometime in the 1950s, you predict that in the next century, there will be a unique network that will allow you to store all the knowledge of the world in a small device. With the help of this network, all people will be able to communicate with each other from different points of the Earth. You're surprised that the internet appears much earlier. Developers create virtual reality worlds with photorealistic graphics. Artificial intelligence is smart enough to rule a small country. Genetic engineering allows us to clone people and mix our bodies with robots. The first cyborgs appear. With each passing century, there's less and less space on the planet. You get tired of people and consuming new technologies, and you spend more and more time in your home on the top of Mount Everest. Humanity is taking over Mars and the Moon. Soon, these places aren't enough for people too. In the 4th millennium, scientists create a quantum engine to travel through space. You're among the first people to try this technology and make the jump to another group of planets orbiting a star similar to our solar system. Your ship breaks down and you can't go back. You're left to live alone on a new planet. Your body adapts to the conditions on it, so you don't need oxygen reserves. Then, you learn to breathe without oxygen at all. The cells of your body receive what they need for normal functioning from the surrounding gases. Your skin is getting rougher because of the dusty atmosphere of the planet. And with the increased gravity, you develop incredible strength. You'd become a super person with such a body on Earth. You manage to send a signal into space, and you hope that humanity will catch it. You've been living alone for over 500 years without books, the internet, or any communication. You spend most of the time exploring a lifeless desert world. Using parts and tools of the ship, you create a vegetable garden. You also have a lot of water reserves. During all this time, you realize that you miss the old world and your life before the meteorite fell. Some spaceship picks up your signal and comes for you. You return to your homeworld. Travel between solar systems is now as easily available as travel by subway or bus. You decide to find a planet as similar to Earth as possible to recreate human life there. Using the power of modern telescopes and your knowledge of astronomy, you discover what you've been looking for in the Andromeda Galaxy Nebula. You arrive at the second home and live a human life there. For hundreds of years, you observe people and mentally go back to your past. You protect those people from external threats, like asteroids, but don't interfere in their lives. From time to time, you fly to Earth and other planets for business. Life on the second home is becoming very similar to life on Earth. There are more and more people and cultures. Technologies are emerging. You have completed your goal, and now you want to discover other worlds. You spend the next 5,000 years studying the ever-expanding universe.
So here's the scoop. You're not even born yet, but your parents already know what you're going to look like. In the year 3021, DNA tech is so advanced they can basically pre-program a person. Eye color, hair, face, and nose shape, lips, finger length, body structure – it's as simple as selecting from a drop-down menu, kind of like creating your own character in an RPG. Everyone looks great. No more diets, no more gyms, and a healthy body for everyone. All it takes is a little gene modification and a special liquid full of a couple of million nanobots. Bioengineering and medtech allow people to change their bodies and minds whenever they want. Improved hearing? Done. Now you can hear a fly rub its paws together from the other side of the room. Not that you'd want to. Nanorobots can turn your eyes into binoculars with 100 times zoom. From your 160th floor apartment, you can read the nutrition info on that wrapper lying on the ground. You've got to get a life, pal. Want to fall out of a window and land unharmed? Nanorobots can make it happen. Millions of tiny robots can be sent to cover your bones and muscles if you want to lift a car with one hand. Superheroes aren't really a big thing anymore. Anyone can get superpowers in 3021. And say goodbye to spending years learning a new profession. You don't need to go to college to find a good job. Just download all the skills and knowledge you need. Medical nanorobots can get into your brain and improve your mood. You can become joyful, angry, funny, sad, all in a matter of seconds. The physical brain isn't a mystery anymore, nor is the subconscious mind. That means no more psychologists or psychiatrists. And solving your personal problems? Easy. You have special lenses built into your eyes linked to AI. You can see an analysis of your mind, and AI will even suggest a strategy for improving it. Not getting enough vitamin C? You'll get a notification. Need more protein? Notification. You'll get it. It's awesome! Amazingly, nanorobots open access to your memories. Watch them like movies, any period of your life, anytime you want. You can see happy moments in perfect detail, or permanently delete anything you'd rather not see anymore. Genetic engineering makes it possible to create not only modified humans, but also animals. Scientists bring back extinct fish, birds, and mammals. You can even grow your very own pet from scratch. A dog, cat, small elephant, dinosaur, whatever you want. And if you don't like cleaning up a mess, pick up a pet robot that looks and acts just like a real animal, without all the annoying stuff. In 3021, your body can live for 200 years, but your mind, forever. You can upload your brain data to the cloud. Your way of thinking, habits, attitude, character, memories, your entire personality can be coded and uploaded. You can encode your mind now and download it into a new, modified body, say after you hit your 189th birthday. And this new body doesn't need food or water, only energy. In the future, no one goes hungry. People travel around the galaxy in style. You can upload your consciousness to a computer and beam it over to your other biomechanical body that you had shipped to another planet. If you've got enough money, you can buy several bodies and scatter them in different parts of the galaxy. Then, on your day off, you can teleport your mind to another planet just to get a bit of peace and quiet. If you want to unload your consciousness and download it again in a few hundred years, you've got a choice to make. Be in a 100-year-long dream, or spend the time flying around in an infinite network. You can even put your mind on the internet and do whatever you want. Some people even choose to live inside the web just for a year or two. Matrix, anyone? People have learned to change their surroundings with the help of utility fogs. Imagine a robot the size of a human cell. This robot has several limbs, can change color, temperature, and can connect with other tiny robots. Utility fogs are just trillions of these little guys. They cling to each other and can create any object you want, or they can turn into a sort of hologram, perfect for video calls. The fog can take on any shape. It can be a cup, a painting, a car, a bigger robot, just not anything living. But just because it's the future doesn't mean everyone gets to have fun. This fog tech is crazy expensive. The fogs can create buildings. You can wake up in your beautiful house, go to work, and the house gets automatically folded up and transformed into a small suitcase. Hey there, George Jetson! You can travel around the galaxy with it and transform it into any home you want. Suddenly feel like having a bigger kitchen, different furniture, a rooftop pool, a slide from your bedroom to the kitchen? No problem. And inside your house, things are way different. You don't have to clean up anymore. Dust, dirt, and grime are all taken care of by nanorobots. You're watching a sad movie, crying, going to town on a Kleenex. Then you just toss the used tissue over your shoulder. Right where it lands, your utility fog turns into a small trash can with wheels. It zips over to the kitchen, dumps out the Kleenex, and poof, it disappears. What about an after-movie snack? For centuries, pizza drones have been flying through the streets. At one point, it got a bit ridiculous. There were too many of them. They started crashing into each other and into passing birds. Now, you just order a sandwich or pasta through your special lenses, and the food gets 3D printed. When resources on planet Earth began to run out, people colonized the Moon and Mars. Then, the big breakthrough – a thermonuclear engine, capable of transmigranuclear flabba. Hey, let's just call it a teleporting device. People sent AI robots over to build cities, roads, electrical grids, and water filtration plants. Then, people began to move there permanently. Everyone born on Mars or the Moon was different from us Earthlings. Mars, for example, gets less sunlight than Earth, so Martians have wider pupils. That means if they ever come back to Earth, they'd basically have night vision. But Martians, and people on the Moon, lunatics, have weaker bones. Luckily, they have those handy nanorobots to help them. But with these new discoveries come new risks and dangers. Uploading your consciousness can go horribly wrong. You risk facing virtual viruses that can imprison you in a virtual cage. Many attackers use programs that can erase your mind, just like a plain old file on your desktop. Those nanorobots, they can still be defective sometimes, and instead of upgrading your body, not great. Moving to other planets is crazy risky. We sometimes have to abandon cities on Mars because there's suddenly a 300-year-long dust storm. And space travel, sorry to tell you, never stops being dangerous. Even in 3021, there are loads of forces in the universe that scientists still don't understand. Say you buy a modified robo-body and send it to a beautiful new Martian city. You're on Earth, and you upload your consciousness to a computer and send it on over to the new body. The weather is perfect, the sunsets are epic. Suddenly, a huge asteroid smashes into your house. These kinds of things happen in 3021. The way we live now seems exotic to the people of the future. To breathe and live in a natural body, to eat natural food, to take a real water shower, to learn new info by reading. That stuff freaks them out. At some point, humans learn to travel through time, but immediately ban the new technology. Humanity's living in a utopia. Apart from the occasional asteroid ruining that robot body you saved up for a whole year to buy, and any change in the past could mean the end of it. Instead of traveling to the past or the future, people create virtual simulations of their favorite time periods. The most popular simulations? Just going back in time and living a day as an ordinary person in 2021. Powerful quantum computers analyze your genes, calculate what you would have looked like, and recreate an exact you. Life was so much simpler 1,000 years ago. Me? I'm going to 1977. Disco, the Bee Gees, glitter balls, the golden age of music. For some of us.
For thousands of years, people knew only about the planets Mercury, Venus, Mars, Jupiter, and Saturn, which they could see using simple telescopes, or even by the naked eye if conditions were good. But in the late 18th century, a famous astronomer named Sir William Herschel discovered a new planet that was icy blue in color. At first, people thought it was a star, but later they realized it was a planet. Today, we know it as Uranus, a planet that's more than 19 times farther away from the Sun than Earth. It's so far away, that it takes Uranus 84 years to complete one trip around the Sun. This astronomer also discovered many other interesting things in space, like double stars and nebulae. In the mid-1800s, scientists noticed something pulled Uranus and strangely tugged its orbit. They thought there must be another planet out there, and they used math to predict where it would be. Finally, in 1846, they found Neptune using a telescope. It was too faint to see with the naked eye because it was too far away from the Sun. It was all so exciting. Who knows how many other planets could be there, lurking in the darkness of our solar system? Back in the mid-1800s, astronomers noticed something unusual was happening in the sky. A small rocky planet named Mercury was behaving strangely. It didn't follow the predictable orbit that was expected of it. One of the astronomers was a brilliant French scientist named Urbain Le Verrier. He came up with a theory that there could be another planet in our solar system no one had yet discovered. It would be located somewhere between Mercury and the Sun. This hypothetical planet, which he named Vulcan after the Roman god of fire, would have an incredibly hot surface, and it could be a potential explanation for Mercury's strange behavior. He never surely claimed Vulcan was really the one thing disturbing the orbit of Mercury. But, excited by the possibility of discovering a new planet, astronomers all over the world took the idea of Vulcan. For a planet that didn't exist, people committed to developing ideas and getting information about it. Some scientists didn't think it was likely that they had missed another planet as big as Mercury. It would have been hard not to see it by then. But there was a tiny chance of a smaller planet existing inside Mercury's orbit that was too close to the Sun, so no one could see it. One theory said it was about 13 million miles away from the Sun. Mercury is the planet with the most eccentric orbit in our solar system, but the closest point it gets to the Sun is about 28.5 million miles. This means Vulcan would be under half of that distance. The theory moved on, saying that if Vulcan existed, it would orbit the Sun every 19 days and 18 hours, and its path would be tilted about 12 degrees relative to the path of other planets in our solar system. Vulcan's position at its furthest point from the Sun would still be too close to the Sun to be seen with the naked eye, even during twilight. The only chance of seeing Vulcan would be during a solar eclipse, or when it passed in front of the Sun, which, as the theory said, would be 2 to 4 times a year. They had a theory that this mysterious planet was so close to the Sun that it could only be seen during a total solar eclipse when the moon blocked out the Sun's blinding glare. So, every time there was an eclipse, scientists would peer at the Sun, hoping to catch a glimpse of Vulcan. They were trying really hard, but no matter what, they couldn't find this mysterious planet. Some astronomers claimed to have spotted it during eclipses, but no one could ever confirm or find evidence for that. The theory of Vulcan was left waiting for some better times. Einstein had a different idea. You know about his theory of general relativity, right? That's where he claimed gravity wasn't some sort of natural force, but a result of space-time curved because of the presence of giant space objects, like planets and stars. Planets circle around the Sun in their usual orbit because space-time is curved. That means the planets are kind of falling towards the central star of our solar system. And Einstein tried to explain Mercury's unusual orbit using his own theory of relativity. Unlike the other planets in our solar system, Mercury's orbit wasn't that circular. Instead, it seemed to wobble slightly, as if there was an invisible force pulling it away. Einstein said this could be happening because the massive gravity of our Sun was actually curving the fabric of space-time around it. He claimed it's possible this changed Mercury's orbit a little bit. It took the scientific community a while to test this theory, but it eventually seemed like the most plausible explanation. Even though Einstein's theory gave us a more elegant explanation for Mercury's strange orbit, some scientists were still holding out hope for Vulcan. It was especially hard to let go of the idea of Vulcan because Mercury is also the planet that's really hard to see from where we're standing. But later, more and more scientists started accepting Einstein's theory above their imagination. And they would observe a total solar eclipse specifically to test Einstein's theory of relativity, not because of Vulcan. And Vulcan is not the only hypothetical planet everyone was talking about. In the newer age, some believe there could be a mysterious planet lurking in the outer part of our solar system. But this one is more likely to exist. No one has seen it directly yet, but computer simulations show this so-called Planet 9, or Planet X, is probably somewhere there beyond Neptune. Neptune and Planet X could be similar in size. Planet X could be 10 times more massive than Earth and circles around our Sun in an elongated shape, which is on average 20 times farther from the Sun than Neptune. A year there may last between 10,000 to 20,000 Earth years. By comparison, a year on Neptune lasts 165 Earth years. Something this big moving out there beyond Neptune could explain the unusual orbits of smaller objects in the Kuiper Belt. The Kuiper Belt is the area of our solar system beyond Neptune and where it orbits. And there are most likely many asteroids, comets, and some other smaller bodies there, mostly made of ice. There was another hypothetical planet called Nibiru. Remember those rumors that the world could end back in 2012? One of the popular scenarios was Nibiru, which some claimed would hit our home planet at the end of the year. Of course, nothing happened. We're still here, all set and good, but the idea of Nibiru seemed interesting. Stories started in the 1970s when a man named Zecharia Sitchin mentioned Nibiru in his book, The 12th Planet, claiming it orbits the Sun every 3,600 years. But there's no chance a planet with such an eccentric orbit wouldn't disrupt other planets in our solar system with its gravity. And if it was really coming that close to Earth in 2012, we were supposed to be able to see it with the naked eye. Some simple calculations showed Nibiru would have been nearly as bright as Mars at its dimmest and brighter than the faintest stars you see from a city. Oh well, maybe we'll have more luck in the next 3,500 and something years. In 2011, a comet named Elenin appeared that many people thought could be Nibiru. But when you're looking at comets and planets through a telescope, you see they appear differently. A comet has a coma, which is a gas atmosphere, together with a tail, something a planet doesn't have. Plus, this comet didn't slam into the Earth. It came too close to our Sun and fell apart. The leftover pieces will continue moving on their way to the outer solar system for the next 12,000 years.
Incredible news has recently spread across the internet. NASA has discovered evidence of a parallel universe. But is this actually the truth? Well, there is a grain of truth in this story, but it's not that simple. Let's consider it. Perhaps you've seen the articles that said NASA has finally found a parallel universe. This story was widely publicized, and people got divided into two camps: those who took this news at face value and those who considered it all complete nonsense. But both sides aren't exactly right. Let's start from the beginning. The discovery was made by NASA's ANITA. This name stands for the Antarctic Impulsive Transient Antenna. Yeah. It was designed to study neutrinos. Neutrinos are high-energy cosmic particles. They're incredibly small, lack any charge, and have almost no mass. Trillions of such particles pass through our bodies every second, and we don't even notice them, all because they almost don't affect ordinary matter. That's how insignificant they are. On average, in our entire life, each of us gets affected by a maximum of one neutrino. So basically, hunting neutrinos is like hunting ghosts. To catch them, you would have to send a whole stream of these particles through a giant piece of lead, and it has to be trillions of miles thick. At the same time, you have a 50-50 chance that you'll stop one of them. Therefore, in order to detect them, scientists had to come up with some clever tricks. We know that neutrinos, like other similar particles, come to us from outer space. They travel to Earth from the Sun, stars, and even from the Big Bang itself. Some of them come to us from particularly big sources, such as black holes, supernova, pulsars, and even from various unidentified objects. Some of these particles have particularly high energy, and for scientists, these neutrinos are the most interesting ones. But oddly enough, most high-energy neutrinos don't actually come to us from afar. They form right here, next to Earth. This process has a cute name: particle shower. Well, this is how you can explain it in simple words. A granny particle gets into Earth's atmosphere. Usually it's a particle with very high energy. Then it generates several children that have less energy. Each of them then makes more grandchildren whose energy is even less than theirs, and so on, until we have a giant family tree of low-energy particles. In the end, there may be billions of them. During this process, piles of neutrinos are created. Then they begin to sink deep into our Earth. During their journey through the planet, they touch the upper layers of its crust or ice, for example, Antarctica's ice. When faced with all these obstacles, they create radio pulses, and as you might have guessed, these are the exact radio pulses that scientists are trying to find. It may be a surprise to you, but Antarctica is pretty deserted, you think? And that's why it's the best place to study microscopic particles, which usually can barely be traced. There won't be any interference or anything like that. We can catch these pulses with the help of powerful antennas. NASA places these antennas on balloons that can rise as much as 20 miles above Earth's surface. That's how they've been tracking these neutrinos for the past years. Alright, now we know what Anita is doing. But what about that parallel universe stuff? Nah, don't worry, we're getting there. In 2018, Anita began receiving abnormal radio signals that caused quite a stir in the scientific community. Remember how neutrinos come to us from outer space and then gradually sink deep into our planet? So recently, Anita has discovered neutrinos that didn't descend from space as usual, but rather rose up from Earth. In other words, these particles, called tau neutrinos, basically travel back in time. But how is this possible? Scientists began to research them. At first, they thought that maybe it was a detector error or an error in interpreting the data. But no, everything was correct. Something very exotic was happening. If so, then first we must try to find a simple explanation. What if these tau neutrinos just came to Antarctica from some other source? Maybe they came to Earth from the other side and somehow passed through the boundary. To test this theory, scientists decided to seek help from another cool neutrino observatory called IceCube. Yes, very cool. This observatory is located near the South Pole. It consists of 5,160 optical detectors buried in ice, and all these powerful detectors are designed to detect neutrinos. Anita researchers were like, "Hey guys, we found some strange radio signals. Could you please check where they come from?" "No problem," IceCube replied, and started their research. And as a result, they found nothing. Yep, IceCube didn't detect any signal sources at all. It turned out that these strange particles had basically appeared out of nowhere. How could this be? Scientists tested many different theories, but none of them could explain the situation accurately. Later, IceCube published an article which basically said, "Nope, we have no idea where these signals came from and how to explain them in terms of the standard model of the universe." Oh, now it's getting interesting. So, what on earth are these signals? Having exhausted normal explanations, scientists began to consider ideas that go beyond our understanding. One of them said that perhaps these particles had come to us from a parallel universe where time flows in the opposite direction. This crazy-sounding theory is the result of the famous multiverse theory. According to it, about 14 billion years ago, when the Big Bang happened, two twin universes were born. One of them was ours, and the other was a parallel one. And they're almost identical in everything, except for some things. For example, time in this parallel universe doesn't move in the same way as it does in ours. It moves backward. Besides, everything there would look upside down to us, as if we're looking in a mirror. Therefore, scientists call it the antiverse, and believe it could be filled with antimatter. And even though all this may seem strange and crazy to us, for those who live in that antiverse, their way of life would be quite normal. In fact, they would rather find us the strange ones. So these mysterious neutrinos could be born in this antiverse. Let's say they somehow existed there and then accidentally got into our world, where we were able to detect them. The idea of the multiverse itself is really incredible. If it's true, then it may mean that there is an infinite number of realities, many of which are much better than ours. Quantum mechanics even says that it's quite possible that every second of every day, any of your decisions divides the universe into two. And so there are quintillions of parallel universes where our lives have gone very differently. Something like this is hard to even imagine. Of course, it would be great if we could find a way to get into another universe, and if these mysterious tau neutrino particles were able to cross the boundaries of two worlds, well, maybe we can do that too? But unfortunately, this phenomenon alone isn't enough to say whether the multiverse theory is true or not. This is just one of several possible options. At this stage of human development, we cannot prove or disprove this theory. Maybe someday in the future we'll find out the truth, but definitely not now. The only thing we can say now, after this discovery, is that we've found strange radio signals which standard physics can't explain. So we need to move in this direction and study them to learn more about this incredible phenomenon. But people like to dream about space, so no wonder we've gotten so excited about this. And it would be great if one day it turned out that this theory was actually true. The theory of parallel universes has been popular in various movies and books for a very long time. Where would you go if you found out that you could travel between realities? Me? I'd look for a different reality of ice cream.
Have you ever heard about the Big Bang? I bet you have. So the history of the universe and its evolution is widely known as the Big Bang model. It claims that our universe began as an insanely hot and dense speck about 13.7 billion years ago. But how did it go all the way from a tiny point to the ginormous world we see and don't see today? We're about to figure that out. Despite its name, the Big Bang wasn't a powerful space explosion. It was the appearance of space everywhere in the universe at once. And the universe itself was born as a very dense single spot in space. No one knows for sure what was before this moment, but scientists are working on figuring it out. Their main assistant is the cosmic microwave background, which still contains the afterglow of the radiation and light left after the Big Bang. Eventually, it may help scientists piece together some clues about the early universe. Just like any kid, when the universe was very young, about 1/100th of a billionth of a trillionth of a trillionth of a second, it experienced an unbelievable growth spurt. Known as inflation, this burst allowed the universe to double in size at least 90 times. As the universe was expanding, it was also getting cooler and less dense. After the insane growth burst, it kept growing, but at a much slower rate. Very soon, the universe cooled down enough for matter to start forming. Everything happened so fast at that time. Light chemical elements appeared within the first 3 minutes after the formation of the universe. Protons and neutrons began to collide, producing deuterium, an isotope of hydrogen. A lot of this deuterium combined and created helium. Then, the process is slowed down significantly, but still for the first 380,000 years after the Big Bang, the intense heat from the creation of the universe made it too hot even for light to shine. The conditions in this early universe were hellish. Atoms collided with such force that they broke into an opaque plasma of electrons, protons, and neutrons. This dense veil scattered light like fog. But 380,000 years after the Big Bang, the matter eventually cooled down enough for electrons to connect with nuclei and form neutral atoms. This absorption of free electrons finally made the universe transparent. By the way, the light unleashed at that time can still be detected today in the form of radiation. A period of darkness followed this era called the Era of Recombination. And then stars and other bright objects started to form. It happened about 400 million years after the Big Bang. This next period got the name reionization. Some time ago, scientists thought that it had lasted more than 500 million years, but new evidence hints that it might have occurred more rapidly than we thought. During this period, clumps of gas collided and created the first galaxies and stars. These events emitted ultraviolet light, which got rid of most of the surrounding neutral hydrogen gas. That's why we call those times the period of reionization. This process led to the universe becoming transparent to ultraviolet light for the first time. At the moment, astronomers are combing the universe in search of the farthest and oldest galaxies. Such a discovery can help us understand the properties of the early universe. It's like working backwards to piece together the events that happened before. That's what researchers are doing now by studying the cosmic microwave background. Our solar system was born around 9 billion years after the Big Bang, which makes it around 4.6 billion years old. As far as we know, our Sun, orbiting approximately 25,000 light-years from the galactic center, is one of more than 100 billion stars in our home Milky Way galaxy. The most popular idea is that the Sun, as well as the rest of our solar system, was once formed from a huge rotating cloud of space dust and gas known as a nebula. At one point, gravity caused this nebula to collapse. It started spinning faster and, eventually, flattened into a disk. Most of the material that made up the nebula got pulled towards the center of this formation, and that's how the Sun was born. At one point, scientists started thinking that there might be more mass in the universe than what we see. After some research, the concept of dark matter appeared. One theory stated that this mysterious stuff could be formed by some exotic particles. They don't interact with regular matter or light. That's why it's so difficult to detect them. Already in the 1920s, astronomers made an astounding discovery. Apparently, the universe isn't static. It's constantly expanding. Interestingly, when decades later, in 1998, the Hubble Space Telescope studied distant supernova, it became obvious that in the past, the universe was expanding more slowly than today. Why was this discovery so confusing? Because it was long believed that the gravity of matter making up the universe would slow down the expansion process, or even cause the universe to contract. That's why these days the concept has changed a bit. Everything on Earth and everything people have managed to see in space with the help of telescopes and other instruments is normal matter. It's made up of atoms and molecules and adds up to less than 5% of the universe. Around 27% of the universe is dark matter, and almost 3/4 of the universe is dark energy. Astronomers wouldn't even know the thing existed if, several decades ago, they hadn't found out that the expansion of the universe wasn't slowing down. Quite the opposite, it was accelerating. It meant that there had to be some enigmatic force counteracting gravity. It got dubbed dark energy. The European Space Agency's Planck satellite helped astronomers calculate how much dark energy the universe has to contain to explain the way its expansion is constantly speeding up. Scientists have also built models of how many giant stars formed and collapsed into black holes since the beginning of the universe. The conclusion is very exciting. The vacuum energy in these black holes is almost the same as the amount of dark energy that should exist in the universe. And still, even though nowadays we know much more about the universe than we used to, there are still important questions that remain unanswered. And, of course, dark matter and dark energy remain the biggest mysteries. Another one is whether something existed before the universe was born, or maybe the theory of the false vacuum is correct. It says that our universe exists in a false phase state, which means it's just a temporary thing. What's more, it's only part of a larger universe. If you compare this larger universe with a kettle full of boiling water, the universe we live in will be just a tiny bubble on the surface of the water. But this can't keep going endlessly. One day, perhaps in billions of years, this false vacuum will burst. And then the visible universe around us will instantly vanish with a pop. There won't be any preliminary warning and we'll have to somehow deal with it. In any case, astronomers are working hard to find the answers to these burning questions. The James Webb Telescope launched in 2021 is believed to be the very tool that can help us to peer back to the beginning of time and explore the evolution of the universe with the help of its infrared instruments. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that formed in the early universe. To look that far back in time, we need to look deeper into space. All because it takes light time to travel from there to us. So the farther we look, the further we glimpse back in time. To find the first galaxies, James Webb is going to make an ultra-deep near-infrared survey of the universe.
This is Earth, 335 million years ago. I wasn't around then, but there's just one supercontinent, Pangaea. See? Let's watch it shift around and fast forward. Okay, here we go. It just split into two huge pieces. Australia goes this way, North and South America go that way. Africa, Asia, Europe, forming, and there we go. The planet as it is today. Let's keep going. I mean, the continents are always on the move. Over time, some of them will crash into each other. Others will break apart. But that'll take about 100 million years. Better put it on super fast forward. 100 years from now, humans keep spitting carbon dioxide into the atmosphere, and the planet's already warmed up a bunch. The world's ocean levels have risen about 4 feet. The Bahamas? They've totally disappeared. 200 years from now, the Earth's population is about 19 billion people. The climate's gotten even warmer. We're packed in like sardines over here. New medical tech makes it possible to live to 180. But why? Fossil fuel reserves of oil and gas? Long gone. Oh, and the continents have drifted over 16 feet. The Voyager 1 space probe's about to enter an asteroid cloud at the edge of the solar system. It's the most distant man-made object in the universe, I guess. 1,000 years from now, thanks to better quality food, humans are now 7 feet tall on average. Technology solved the pollution and fuel shortage problem. Humanity's doing just fine. Robots do all the work, we just play around all day. Ocean levels have crept up another 10 feet. Islands like the Seychelles, Maldives, Galapagos, and many others have gone underwater. Denmark, the Netherlands, Eastern England, Thailand, and Vietnam are only partially underwater. There's been a huge human migration these last 100 years. Fast forward about 5,000 more years, and it's the year 8113. Humanity's getting ready to open the crypt of civilization. It's a hermetically sealed room in Georgia, in the States. Bad Georgia. It was created in 1940, and it's full of about 800 books on microfilm, recordings of famous people's voices. It's also filled with bits of technology from that time, like a toaster, a radio, and a typewriter. Some awesome people created the crypt of civilization in case humans experienced a major catastrophe in the distant future and had to rebuild civilization from scratch. We'd all go back to using typewriters. 15,000 years from now, our planet has changed its tilt, and the Sahara Desert is now a tropical paradise. Years of rain turn the dry desert into a wild jungle. 30,000 years from now, the Voyager 1 space probe has finally left the asteroid cloud at the edge of our solar system. If it doesn't collide with anything, it'll be flying in the dark, wide-open outer space for a very long time. 50,000 years from now, the climate's changing a lot. The temperature on Earth is beginning to drop, and we are approaching the beginning of a new ice age. The radio signal with a special "Hello, all you aliens out there" message sent into space in 1974 has reached its destination. The message contained the human number system and data about our DNA and our solar system. If there was someone on the other end to receive this signal, we might have a response from them. 100,000 years from now, one of the largest known stars in our galaxy, Canis Majoris, explodes with enormous force. The explosion of this supernova can be seen from Earth, even during the day. And the nights are much brighter because of the new strong glow in the night sky. What's new on Earth? Supervolcanoes start erupting all over. These volcanoes spew colossal amounts of lava and ash everywhere. Thick black clouds cover most of the sky. This prevents the sun's rays from reaching the ground, and the temperature on our planet drops even lower. Humans mostly live underground anyway, so it's no big deal. Because the stars are gradually moving in different directions, the usual constellations are starting to change shape. Soon, we'll need to come up with totally new constellation names. 250 years from now. Oh, a new island's on the map. Back in 2021, it was just an underwater volcano somewhere in the Pacific. After thousands of years of spouting out lava, it finally reached the ocean surface and busted out in the cool, fresh air. Not much growing on it yet. Niagara Falls has long since disappeared, and Lake Erie and Lake Ontario have teamed up to form one huge superlake. 300,000 years from now, the triple star system WR104 is about to explode. It's spinning crazy fast, and there's a chance that radiation from the explosion could eventually reach Earth. That would do a lot of damage to all life on our planet. Voyager 1 reaches the brightest star in the night sky, Sirius. Not a very funny star at all, it's really Sirius. It's 8.6 light-years from Earth. 500,000 years from now, scientists are pretty sure that a huge meteorite could fall to Earth any day now. It might be even the size of 8 football fields. The impact of such a massive meteorite would cause an explosion so powerful that its sound would be heard on every continent. That would be followed by super strong earthquakes and tsunamis higher than the Brightside Empire municipal building tower thingy. Okay, I just made that up, but who knows what we'll be building in the future. 1 million years from now, the rogue star Gliese 710 comes very close to our solar system. We're surrounded by a huge shield of asteroids called the Oort cloud, and the rogue star is beginning to affect the asteroids hanging out in there. It grabs them, spins them around, and throws them toward the center of our solar system. Comets start to fall on our planet all the time, big ones, causing more tsunamis and earthquakes. 10 million years from now, the Red Sea is gradually expanding into the East African Rift. Africa is now divided in two by a new oceanic gulf. The human DNA molecule has completely decomposed. But it's no big deal. We've become totally digital, without any pesky aging problems. The really cool thing is that other animals have evolved a lot and changed ridiculously. Thanks to a simple interface, we're actually able to talk to dolphins, chimps, dogs, and cats. Turns out cats aren't grumpy, they're just busy contemplating life. 25 million years from now. The San Andreas Fault has been crazy recently and has caused the Gulf of California to flood the Central Valley. There's a new sea on the west coast of North America. 50 million years from now, Africa just collided with Eurasia. The Mediterranean Sea is totally gone. There's a new tallest mountain in the world. Its name? Mount Everest, of course. Australia is continuing its journey north. It already collided with Southeast Asia a few million years ago. The few human colonies still left on Mars need to do some serious packing. Phobos, one of Mars' moons, is beginning to orbit at a lower and lower altitude. That's not good. It's about 14 miles wide, so that's going to be unpleasant. 60 million years from now, the Canadian Rocky Mountains have completely eroded. It's just one gigantic flat plain. 80 million years from now, all that remains of Hawaii is one island. All the others have long since gone underwater. But just next door, a whole new chain of Hawaiian islands has emerged. Finally, 100 million years from now, we made it! The Atlantic's shrinking down to nothing. The Americas are almost rubbing up against Africa. Africa's already merged with Eurasia. We've got ourselves a supercontinent again. Hello, Pangaea Proxima. All traces of human life are gone or buried deep underground. The movement of the continents has destroyed tunnels, roads, buildings, bridges. Animals and plants now reign supreme on Earth. So, where are all the humans? Well, Remember, we made the jump to digital about 90 million years ago? Things are still going strong. There are trillions of human minds living on a huge hard drive on a spaceship orbiting Earth. The super low space temperature is good for keeping the drive nice and cool. We have millions of different societies, languages, and cultures, just like we had 100 million years ago. The only difference? We're all little ones and zeros in a huge digital universe that we created. And yes, there's still football.
For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP 890-9b and LP 890-9c. Buckle up because we're heading to LP 890-9, a red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees Fahrenheit. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP 90-9b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP 890-9b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP 890-9c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP 890-9b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on. It's not all sunshine and rainbows for LP 890-9c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate. And Venus isn't known for being human-friendly. But despite these challenges, LP 890-9c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists, led by researchers at the Instituto de Astrofísica de Canarias, has found 2 Earth-like planets just 16 light-years away from our solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but you know. And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small, cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, it's located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet, just like Earth. And if it really does contain water, there could even be life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP 890-9c. That would be, unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great! Finally, at least somewhere, winter and summer will flow normally. Kepler 1638b could have some liquid water there. That's why it's also a good candidate for further study, to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years away from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions. Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope that at least a few of them will really be inhabited.
Jupiter's gravity shattered a huge comet. It wasn't enough for the space monster. A real catastrophe happened. The shards didn't fly in different directions. They lined up and rushed towards Jupiter like the rail cars of a train. 21 fragments up to 1 mile in diameter burst through Jupiter's atmosphere. Fireballs at the speed of 37 miles per second bombarded the planet's shell. They heated the space around them to 50,000 degrees Fahrenheit. That's higher than the temperature in the sun's upper atmosphere and 312 times hotter than you need to boil an egg. Well, I'm not hungry anymore. The impact was like from a rock falling into a pond. The meteorite fragments formed giant plumes on the surface of Jupiter. Substances from its lower atmosphere rushed upwards. The process generated a tremendous amount of energy. Overheated streams of fire shot into the stratosphere. The monsters left behind them glowing plumes 1,900 miles long. That's greater than the distance between New York and Texas. Dark bruises appeared at the side of the blows. They were about the size of the Earth. Comet Shoemaker-Levy 9 was the name of the violator of Jupiter's boundaries. The collision of celestial bodies happened in July 1994. It was a scientific sensation. For the first time in human history, a catastrophe of this magnitude was observed. The attack raised an important question for astronomers. Why is Jupiter unlucky? Space monsters attack it thousands of times more often than the Earth or any other planet in the solar system. All right, let's see. You decide to board a starship and travel to the mysterious Jupiter. A space probe would need 2 years to get there, but your starship is faster. You'll be there in… Great, the journey only took a second. Jupiter is actually big. It could fit 1,300 Earth-sized planets in it. It looks beautiful thanks to gas clouds. This planet has no solid surface, but there's a strange stain on its surface. It looks like a huge eye that can fit 3.5 Earths. This storm will scare anyone. It's 10 times higher than Everest, and the wind rushes at a speed of 300 miles per hour. It's been going on for 350 years. You wouldn't hide from such a storm in a car, so it's good you're in a starship. If all the planets of the solar system merged into one superplanet, the new object would still be 2.5 times smaller than Jupiter. Large size also affects gravity. Spacecraft use Jupiter as a springboard to jump. The giant's gravity increases their flight speed and helps them reach their target faster. Gravity has turned the planet into a magnet for comets, asteroids, and dangerous space debris. Jupiter is a true space superhero. Its gravity shield takes a hit and deflects space monsters that fly into the inner solar system. The dinosaurs don't agree, but more on that a little bit later. What if Jupiter was swallowed up by a giant vacuum cleaner tomorrow? I can only say one thing: we'd have huge problems. Without a giant shield, thousands of comets and asteroids are attacking the planet much more often. Most of them burn up in the atmosphere or aren't large enough to affect us. But there are also larger comets and asteroids. After their collision with the Earth, you can say goodbye to all life on the planet. For example, in 2009, a celestial body crashed into Jupiter. It left a bruise the size of the Pacific Ocean. It's scary to think what traces it would leave on our planet. Most likely, the Earth would turn into a fireball. But recent research from astronomers suggests that Jupiter isn't such a nice guy. On the contrary, it's a bad guy with a slingshot that shoots comets at the Earth. A physicist used computer simulations. He found that Jupiter is equally likely to deflect and send comets toward the Earth. The giant attracts potentially dangerous objects and only partially protects us. It's already tried to knock out our planet many times. 66 million years ago, a cosmic body 10 miles in size crashed into the Earth. The energy of the impact set the surface of the planet on fire. It caused a huge earthquake and tsunami. A fiery rain fell from the sky on the Earth. There were millions of tons of debris and dust in the atmosphere. They stopped the sun's rays from reaching the planet. The nuclear winter began. This disaster led to the extinction of the dinosaurs. Scientists have named this space criminal Chicxulub impactor. Computer simulations of scientists at Harvard University showed where it came from. Chicxulub wasn't an asteroid, but a comet. This means that the core of its body wasn't stone and metal, but ice, dust, and frozen gas. It resembled a dirty snowball flying through space. The meteorite wasn't going to set fire to the Earth, but Jupiter intervened in the plan. It threw comets in our direction. In 1770, Lexell's comet appeared near the Earth. Our planet and this object were separated by only 1.4 million miles, close to nothing in space terms. Lexell's comet came closer to Earth than any other comet in human history. The object could have stopped life on Earth. The comet flew too close to Jupiter. The giant caught it and sent it in our direction. Now, this isn't a very good move for a superhero that protects the solar system. After 3 years, the comet went past us. It flew 2 times around the Sun and returned to Jupiter like a boomerang. This time, the giant pushed the comet out of the solar system. But let's not blame Jupiter. Scientists believe that without this gas giant, life on Earth would most likely never have happened. Jupiter sent meteorites toward Earth, which carried organic molecules and water with them. They were the building blocks from which earthly life began. Nobody knows if comets would come with a valuable cargo without Jupiter and its dangerous gravity. If you fly away from Earth to the center of the solar system, you'll see the Sun. 8 planets are flying around this star. There's a belt of more than 1 million asteroids between Mars and Jupiter. One theory says there was only the Sun at the very beginning of the solar system's existence. Clouds of stone and dust surrounded the star. These particles attracted each other and formed planets over millions of years. Jupiter didn't want any new neighbors. Its powerful gravity prevented rocks and dust from uniting into planets. They remained asteroids and gathered in a belt inside the solar system. If today all the asteroids merged into one planet, we'd get a cosmic body that would weigh only 4% of the mass of the Moon. Previously, the belt was densely populated, but Jupiter's gravity threw 99% of the asteroids to other places in space. Jupiter isn't the only one that plays a role in the development of life on Earth. Our main assistant is the Moon. It's the only natural satellite of the Earth. Jupiter has 79 satellites, and every year there are more and more of them. Jupiter is also surrounded by rings, but they aren't as beautiful as Saturn's and are practically invisible. The rings are composed of small black particles. This is the dust that the meteorites eject into space after colliding with the moons of Jupiter. The Moon is responsible for the ebb and flow of the ocean. It regulates the life of bees, fish, birds, and amphibians. Even you feel the influence of the Moon every day. Changing the brightness of the disk in the night sky regulates the level of melatonin in your brain. This hormone is responsible for circadian rhythms, which are important for healthy sleep. The Moon came about thanks to another catastrophe, like many other things in space. Millions of years ago, the Earth looked like a ball of hot lava. There was no water or air. It was enveloped only in carbon dioxide and nitrogen. At this time, another planet the size of modern Mars crashed into the Earth. Scientists named it Thea. At a speed of 8,900 miles per hour, it collided with the Earth. The impact of incredible force threw millions of tons of material into space. The debris gathered into a ball that became known as the Moon. Scientists have almost solved the mystery of the Moon, but they don't know if there's a solid core in the middle of Jupiter or if it's dense hot soup that hangs in space. Jupiter has the largest ocean in the solar system. It's made of liquid hydrogen, not water. If Jupiter were 80 times more massive, it would turn into a bright star. Jupiter is a unique place that will never be home to humans. The pressure inside the planet is 2 million times greater than on the surface of the Earth. Extreme pressure and temperature would ruin any spacecraft that's gone too far. I guess that means Jupiter would have a crush on you.
Imagine the universe as a gigantic, elastic balloon that's steadily being inflated. That's what dark energy seems to be doing, forcing galaxies further apart. Could this force lead to the end of the universe? Some scientists do think so, and they've named this potential event the Big Rip. It's challenging to study dark energy, even though it's one of the most fascinating aspects of our cosmos. That's because its only visible effect is this gentle stretching of space. On any smaller scale, it's virtually undetectable. Compared to dark energy, studying dark matter feels like a walk in the park. Even though it's just as invisible, dark matter leaves clear evidence of its existence. It latches onto galaxies and galaxy clusters, bending light and altering gravity. Dark energy, on the flip side, just expands. Nonetheless, scientists have found ways to examine it, mostly by observing the universe's expansion. As we peer into the distance, we are, in fact, peering back in time, tracing the universe's evolution. Dark energy could also bring about the end of the universe in a massive, catastrophic event. Imagine watching helplessly as reality itself tears apart with no hope of escape. Frighteningly, it's not some far-fetched scenario. The available data does not eliminate the possibility of a big rip. Is dark energy a force that keeps inflating the universe, or is it more like a separator? If two galaxies are far away from each other, they're driven further apart, leading to increasing cosmic isolation. But anything that's already a strong structure stays intact, immune to this divisive force. Why doesn't it mess things up, you ask? Well, it's because dark energy remains consistent. As space grows bigger, the density of dark energy remains steady. Imagine drawing a circle anywhere in space, taking note of the amount of dark energy there. Do it again after a billion years, and guess what? The amount of dark energy inside your circle won't change, even though space itself has expanded. That is, unless, of course, dark energy has a trick up its sleeve and proves to be more potent than a cosmological constant. All we know for sure is that it's something that drives the universe to expand more rapidly. Or to put it another way, it creates negative pressure. Now, negative pressure might sound odd. Pressure is usually seen as an outward force, right? But in the universe, it behaves differently. Pressure is a type of energy, like mass, that attracts rather than repels. All these calculations are what makes the Big Rip picture a slow, unraveling movie. The first objects affected are the most massive, loosely bound structures, like giant clusters of galaxies. Their gravitational pull will start weakening, causing them to drift away into the growing cosmic voids. Next, we'd notice stars on the outskirts of our galaxy not following their usual paths, but instead drifting away, like party guests saying their goodbyes. The night sky would then start to dim as our Milky Way would gradually evaporate. The disaster would just accelerate from there. The orbits of the planet would begin to shift, spiraling outward. Just months before the end, after we've lost the outer planets, Earth would drift away from the Sun and the Moon from Earth. We would plunge into the darkness alone. The stillness of solitude won't last, however. Any remaining structure would be destroyed because of the expanding space. The Earth's atmosphere would start to thin. Gravitational shifts would cause chaotic tectonic movements. In the final hours, Earth would fall apart. Beyond this point, the destruction would continue unseen. Nuclei, the ultra-dense cores within atoms, would disintegrate next. Black holes' dense cores would get obliterated. In the last instance, space itself would just rip apart. Bad as it may sound, we may never rule out the threat of a big rip. However, it might take so long that all cosmic structures will have decayed before it happens. A rough calculation suggests the earliest big rip could be in about 200 billion years. Technically, the Sun still has about 5 billion years before it fades away naturally. So by the time this event might happen, our solar system would have long been gone. Nonetheless, given the possible implications, scientists are placing a high priority on understanding the Big Rip. Let's be optimistic though. I mean, if we look at the universe's history, we should consider ourselves lucky. We're in what cosmologists refer to as the luminiferous era. It means that right now the universe is still pretty busy producing new stars, and we know how important these celestial bodies are for maintaining life as we know it. However, the golden age of star formation was about 10 billion years ago. Ever since that peak, the rate of creating new stars has been on the decline. Now, why is the universe taking this early retirement? It's not because it's lazy or tired. In fact, it's exactly because we're living in this expanding universe. For a new star to appear, a bunch of matter needs to be squeezed into a relatively small space. It's like trying to stuff all your clothes into a very, very small suitcase. As the universe expands, the matter is getting spread out, leading to less and less room in that suitcase for creating new stars. The Big Freeze, another theory related to the end of the universe, looks at this scenario. Stars will become endangered and then extinct species. This period of star decline is what astronomers like to call the degenerate era. It's estimated to start about 100 trillion years into the future. What'll be left in the night sky at that point? Only the hardened workers of the universe, white dwarfs, neutron stars, and black holes. White dwarfs and neutron stars, the remnants of medium and large stars that have exhausted their nuclear fuel, will eventually cool off and transform into black dwarfs. These black dwarfs are like invisible cosmic spirits, just hanging around without doing much, inert and unseen. Other neutron stars, too heavy for their own good, will stumble under their weight and collapse into black holes. Further into the future, the universe will become a black holes-only party. But even these cosmic weirdos can't cheat time forever. Black holes can fade away too. In fact, this idea of fading black holes came from a brilliant mind you might have heard of, Stephen Hawking. He suggested that black holes slowly shed energy in the form of radiation until they shrivel up like raisins and evaporate completely. Eventually, every single black hole will have evaporated. We'll be left with a universe in its twilight years, settling into its final age, aptly named the Dark Era. At this point, both light and matter will be nothing but distant memories. And then, well, nothing. If this big freeze theory is correct, the universe will just remain in a quiet, dark state, stretching into an eternity, where nothing else ever happens. Most of these theories seem to rely on the fact that the universe is expanding. But what exactly is it expanding into? We can't help but wonder if there's something else beyond our universe. Right now, this question is one for which physics doesn't quite have an answer for. We don't have enough facts. One suggestion is that time and space came to be with the Big Bang. That happened around 14 billion years ago, so logically there's nothing beyond the universe. However, a huge chunk of the universe is way out of our sight, existing beyond the part we can observe, which is about 90 billion light-years in diameter. Because everything's pretty much the same wherever you look in the universe, we can presume that the bits we can't see would look pretty much like the parts we can. But that's just an assumption. Now, if the universe is infinite, there's nothing beyond it, right? I mean, that's just what infinite means. On the other hand, if it's finite and growing, you'd start to wonder if there's a boundary or an edge, like a universal cliff that separates our universe from whatever is beyond it. It gets even more complicated when you realize the universe has at least 4 dimensions, 3 for space and 1 for time. And it's pretty much impossible for us to picture what that might look like.
A space settlement floating out there in the cosmos. It's not sci-fi. But, as always, there is a catch. Look at this tiny deserted asteroid. It may look lonely and barren, but if you peek inside, you'll see life blooming inside of it. These days, many people now live right inside these asteroids. It's not sci-fi. According to researchers, we might be able to create futuristic cities the size of Manhattan on gigantic space rocks. Of course, there's a catch. The asteroid we choose as our base has got to be at least 1,000 feet wide. Though it's weird why life is inside this asteroid and not on its surface. You see, we can't really live right on asteroids. That's because we're not the little prince who indeed lived on an asteroid, according to the plot, but because there's too little gravity and too much radiation for us to handle if we chill outside. There are possible theoretical ways to stay on the surface, but it's going to be extravagant. So the only option is living inside asteroids. Nothing screams wildly theoretical like building an asteroid city. Living in space without any gravity isn't as romantic as it sounds. Researchers show that when people spend too much time in zero gravity, things start getting weird. Their eyeballs pop out, retinas detach, muscles shrink, and bones become as fragile as a potato chip. But imagine this, a space settlement floating out there in the cosmos. If you've watched enough sci-fi, you'd picture a massive structure spinning round and round. It spins to create gravity for all the lucky folks living inside. There's an actual prototype of this wizardry, the O'Neill cylinder. This device is named after physicist Gerard O'Neill, who came up with the idea for NASA in the 70s. Now, there isn't a ton of data on this, but humans need roughly 1/3 of Earth's gravity to function properly. An O'Neill cylinder may not be able to generate massive amounts of gravity, but the genius behind it, Mr. O'Neill himself, designed them to spin around their long axis. This device creates a gravity-like force called centrifugal force. So, if we ever get to use that, we'll be living happily on the inner surface of the cylinder, feeling pulled downward away from the center. But, as always, there is a catch. When the team crunched the numbers, they realized that the asteroids would break apart way before they could reach the speeds necessary to keep us grounded. And to make matters worse, most of these asteroids were more like loosely assembled piles of rock than a solid chunk. The small ones, like less than 6 miles across, are a mix of sand, pebbles, rocks, and boulders. They're all held together by the weak force of their own gravity. If you were to spin one of these asteroid buddies, all those parts would go flying off into space. Not cool. However, scientists didn't give up and they elaborated on the idea. They needed to find a way to keep the asteroids together. They played around with different ideas and they produced something crazy. Now, if you were to carry all your personal belongings every day right in your hands, at some point, the situation would be out of your control. You'd have to collect all your stuff from the floor. But you're smart and you carry a bag, right? Well, it seems that if we want to control an asteroid, all we need is a ginormous bag. But not just any bag, a massive, flexible, and super lightweight mesh bag made from teeny-tiny carbon nanofibers. These fibers are like tubes that are only a few atoms wide, but boy are they strong. So once we've got this cylinder-shaped bag all set up, we can start slowly spinning the asteroid using rocket motors deep within the rubble. And as it spins faster and faster, it'll start flinging all those pebbles, rocks, and boulders. And guess what? The carbon nanowire webbing is going to go flying out with them. This bag will be expanding and expanding until it reaches its absolute limit. And then the rubble inside slams into the now super tight webbing. It's like a crazy explosion of debris compacting together to create this massive hollow cylinder made entirely of concrete. Once all the dust settles, you can build entire towns, cities, parks, and even farmland on the inside of the cylinder. This is like something straight out of O'Neill's designs. You can even enclose the whole inner surface with a transparent roof. Outside of this incredible living area, you've got these thick concrete walls that are like superhero shields protecting against radiation. So not only do you have this space to live in, but you're also super safe from any harmful stuff outside. We still don't have this magic bag, as those magic carbon nanowires aren't mass-produced yet. But scientists claim that, according to the laws of physics, a tiny asteroid, like a few football fields put together, can be transformed into 22 square miles of living space. As of now, about 1.5 million people are living in Manhattan, and there are like tens of thousands of asteroids just hanging around in our solar system. You do the math. Seems like everyone will have a sweet spot to crash in space. Building a city in space is no easy feat. The main challenge still is to create a self-sustaining closed system that can keep going for the long haul. You see, cities on Earth rely on a much larger area to survive than just their own boundaries. But in space, the farther away from external resources a space city is, the more it needs to close its loops for oxygen, water, and food. Take the ISS, for example. It's about 40% efficient in recycling oxygen. But even then, its CO2 levels are always sky high. NASA is on the case, though, trying to figure out how to magically turn that CO2 back into oxygen. Once we've tackled the basics, like protecting ourselves from radiation, dealing with pesky gravity, and finding some air to breathe, it's time to get creative in space. Enter 3D printing and rocket engines, the dynamic duo that will pave the way for space settlements. With 3D printing, we can kiss goodbye to relying on Earth for spare parts. We'll simply whip them up locally, cutting out the middleman. We can even use 3D printers to whip up a delicious pizza in a couple of minutes. Of course, we'll need some fresh ingredients, but your dinner might just be a push button away in space. To truly thrive out there, we'll need to tap into the riches of asteroids. These celestial treasures are bursting with raw materials, perfect for creating solar arrays, building materials for our colonies, and so much more. And let's not forget about comets. These icy wonders are like cosmic water fountains, providing us with precious H2O for drinking, bathing, and even shielding ourselves from radiation. Plus, we can use that water to produce hydrogen and oxygen for rocket fuel and fuel cells. So, let's say we pull this off. Can you imagine people living or born in space might end up being different from you and me? Like if humans can have babies up there, these space colonies might develop some cool cultures. They might even come up with their own languages, and get this, they could even evolve new physical traits. It's wild to think that just after 300 years, a colony of 2,000 people could look and act so differently from us. They might have different hair textures, skin types, and even be taller or more slender to deal with that low-gravity situation. We might even develop new organs to protect us from cosmic rays, or we'll have gill-like structures to breathe carbon dioxide. Hey, I know, it sounds crazy, but these scientists are working on developing these carbon nanotubes as we speak. So maybe one day we'll be living it up on our very own asteroid crib. It might seem like asteroid cities are just too far-fetched, but let's take a trip back in time for a moment. In 1900, no one had ever flown in an airplane, but today, thousands of people are zooming through the sky, comfortably seated in chairs, traveling at hundreds of miles an hour high above the ground, unaware that their luggage is on another plane going to a different destination. Ah well,